Okay, so good morning. Okay, so for me, good morning and good afternoon, everyone. I'm very pleased to welcome you to the second day for the training workshop. I hope yesterday was very a very interesting topic that you had an opportunity to hear from experts from the academia and also the industry. Today we will have the same opportunity to learn from Professor Huang, who is the Vice Dean of the Engineering University of Zhejiang University, and also from Everbright, an expert from IRA regarding the VPP law and the business model, how waste to energy could be implemented. And also, I'm gonna present you also the presentation of the waste to energy technologies with case studies in Africa, Europe, and Canada. So I will give you the floor, to Professor Huang, if he could even present himself, and to start, present you his intervention for today. Thank you.
Okay, thank you very much, Rita, and thank you very much for your introduction. I hope everyone can hear my voice clearly. And good morning and good afternoon, dear friends from North Africa. And it's my great pleasure to give a brief introduction about waste incineration technology. And I would like to share my slides, and let me see, how can I share slides like this? Okay, and I hope you can see my screen.
Okay, perfect. Good. Just okay.
Okay.
Excellent. Very good. Excellent. Yeah, so, it's a full screen. Okay. That's
good. Yes, thank you very much. And during my introduction, if you cannot hear my voice or some problem with the network, please, you can send me a message, give me a message, and I can give you introduction again. And after the introduction, I will share my presentation, and you can have some materials in your hand for your better understanding of the incineration technology. And some of the material was downloaded from the website, and there is no intelligent conflict. And so if you want to use the material for the teaching, it's okay. But if you want to put the material in your published paper, and then you have to ask the original the authors. So, and a brief introduction about myself. I'm a professor of Zhejiang University and Energy Engineering College. I was working on solid waste incineration and thermal treatment technology for over 15 years. And most of my research work was working on the incineration, pyrolysis, and the gasification of municipal solid waste sludge, and also some plastics like waste tar and oily sludge. And the recent years, I also done some works on the microplastics and also plasma technology for the treatment of the waste. In college, I also in charge of the master student program. So if some students want to pursue a master degree, you can contact with me. Here you can find my email address and my local phone number. And if you like, you can send me a message or you can direct call me. And 100 slides, so a lot of materials. Usually I would like to give the presentation in 2 or 3 hours, but in this time I only got 1 hour, and I would like to move a little bit quicker. And a brief information about waste generation globally, and I think yesterday Professor Lee already gave you this information, so I would like to move quickly. One of the global waste generation is the value or the mass discharged by every person was correctly connected with its local GDP. And as you can see from the distribution of all these waste, more rich people charge more waste, and more metal and recovered or valuable materials will be contained in the solid waste. And also you can see globally the treatment of the solid waste, and this information was provided by World Bank, and you can find the information. I provided the original reference link here, and if you like, you can find the original information from the World Bank report. Overall, the waste to energy or waste incineration fraction is relatively low, only 11% globally. But in some developed countries, especially in China and the European and Japan, the waste incineration ratio is much higher, over 50%. And also in some countries, dumping is still exists, and especially non-sanitary. And for waste treatment or waste thermal treatment technology, comparing with other technology, waste it's like an industrial technology. It should waste very quick and very fast, but it costs a lot of money. Especially, it can be used for generate electricity, and also it can be used to get heat for local residence heating or the local industrial zones. And here is some brief information about waste to energy or waste incineration in European, and you can see it is still increasing and or become stable after 2015. And also some information in North America is a different story, because they have so many land and relatively low populations, so population densities. So the land filling is still dominating, but the waste to energy is increasing these years. And I know several new plants was starting up again. And in Japan, you can see Japan is really advanced in waste incineration or waste to energy. The number of the waste incinerator is decreasing, but the capacity is still increasing these years. And incineration accounts for more than 80% of the waste was used for energy recovery. And in China, we have like a 30 or 50, approximately 30 years, 35 years of waste to energy histories. And now approximately 50% of the waste was submitted for incineration to get electricity. And especially after 2015, the number of the waste incineration was increasing sharply, and also the capacity was increasing. And in China, approximately 0.8 kilogram of waste was discharged per person per day. For example, for the city, our university located in Hangzhou, we have like 10 million people living in these cities, and approximately 10,000 tons of waste was discharged and every day. And all this waste now are incinerated, and the bottom and the bottom ash and the fly ash or the solid residue was submitted for the landfilling. And also in cities in China, we also have a lot of rural areas. I think it's very similar to what was happening in the North Americans, and a lot of waste was open dumped. And here is the city I have visited 6 or 7 years ago. And here you can see the waste was directly dumped, and some of the waste was directly burned, open burned. And from the smoke, you can see a lot of the organic pollutants, like pH, like dioxins, was to the air. And also, beside this landfilling site, there was a small river, and the water of the river was directly induced to the soil for the agriculture. So it's really a big problem for local residents. So we have helped them to build systems. And after this, and all the waste you can see here was burned, and the water mass was properly treated. The waste generated in the rural area and in the big cities was very different. And according to our statistics data, only 0.3 kilogram of the waste was discharged every day per person, right, in the city where this incineration site was located. And energy, we in China, we have different technology, and Tian 2019, we have like now by this years we have over approximately 600 plants was under operating, and we also have another 50 to 80 plants was under construction, and 60% of all the waste discharged in China was submitted for incineration. And you can see the number of different provinces. All provinces has waste to energy plants, and you can see even in the very rural areas like Xinjiang and Tibet, we also have waste to energy plants. Especially near the coastlines, you can see here we have a lot of the plants was under operating near the coastlines, because the economic in this big city, in this province, was much better than the city or province located in the middle of the mainland of China. And in order to improve or monitor the operation of these waste to energy plants, our government has built a website. From this website, you can see all the plants, how operating. You can see the operating data, including the temperature inside the furnace, and also the emission of these pollutants, including particles and acid gases, and also monoxide. And you can see what's the emission data. That it was continuously data, and you can see all the times if how many incinerator was operating, and how about the temperatures, and all each spot you can see here. Each spot is representing a plant, and if you click this website, you can find all this information, which is very helpful for the public to know how the plant is running, and is there any problem, or how about the emissions. And there are two main technology which was widely used in China for waste to energy. For the first is moving grid technology, which is provided by many companies, like the technology from Everbright and also from the Martin Sanfeng and from the SUS from Shanghai, and the moving grid. And for the moving grid, we also have different technology, like reciprocated and inclined and also staged moving grid. And in this picture is a brief layout of the waste, how the waste is collected and how it is submitted to the hopper for the feeder, and then pushed inside of the furnace and then burned. After burning, the high temperature, the energy contained in the thermal energy contained in the flue gas was used for generate steam, and the steam was used to generate electricity or directly sent to the local residents for heating or plant for other utilization purpose. And after the temperature of the flue gas is reduced by the exchangers, and it is the dirty flue gas is submitted to air pollution control systems, including the scrubber and also active carbon injector unit, and also baghouse to remove the participate matters. And then the flue gas is induced to stack and released to the air. So even there are so many different technology for waste incineration. The overall was the similars, and also we have the circulating fluidized bed technology, which was developed by our university, CAS, and also Tsinghua universities. And this technology is also widely used in China. And for pre-treated municipal solid waste incineration, and also for sludge, and also for some biomass like rice husks, and also for the low quality core for electricity generation. And then when we are using a circulating fluidized bed technology, the waste must be pre-treated. So it must be shredded, and the sum of the ferrous and non-ferrous uncombustible materials has to be removed. And then the prepared waste is put in the pit and then feed inside the circulating fluidized bed. And in the circulating fluidized bed, the temperature of the flue gas is running approximately 800 to 900 Celsius degrees. And then, similarly with the moving grid technology, the high temperature flue gas, the energy contained by the high temperature flue gas will be recovered by the heat exchangers to generate electricity and also provide heat. And after that, the dirty flue gas also will be submitted to the APC system, induced to the APC system. And after the APC system, all the pollutants will be removed, and the clean flue gas is induced to the stacks and released to the airs. And in these courses, as Tian now, especially globally, as moving grid technology is more widely used than circulating fluidized bed. So I will focus on the moving grid technology, and to give a brief introduction about how the waste is submitted to the incinerator and how it can be used. And also in the final several slides, I would like to share you several cases, especially the case located in Hangzhou cities. You can find how the waste can be incinerated and how it can be used for energy recovery. And here is the waste to energy. When we are thermal technology to treat the solid waste, usually it can be classified into combustion or classification or pyrolysis technology. For the direct combustion or for the incineration technology, the waste is directly burned out. All waste was burned out, and a lot of the air was injected into the incinerators, and then all the organic matters contained in the municipal waste is burned out and become carbon dioxide and steam and also ash, and then the flue gas is cleaned. Another waste to energy solution by using thermal technology is we gasified or pyrolyzed the waste into thin gas or the oils, and then the thin gas and oil is cleaned, and then it is used for burning to get energy and also to get or get extra oils like pyrolysis oil, which can be used in the internal engine or some other industrial boilers for supplying the energy or heat. And you can see these two technologies is different. Currently, the combustion technology or direct mass incineration technology is more well industrialized. Gasification and pyrolysis, there are several plants under operating, but the scale is relatively small comparing to the combustion systems. And here is the layout of a picture of the great incinerators, and this is the moving grid incinerator, and also this is the furnace of the burn out of the furnace, and also here you can see the steam drum, which was used to convert the steam into the superheated steams to generate electricity. And the waste is coming, and then the flue gas is treated in this APC unit. And here is the CFB incinerator, and here is a great incinerator and the CFB incinerator. As I have mentioned, the material or participating mediums was circulating inside the furnace, and the big ash particles is removed, resubmitted back into the furnace. by through the cyclone separators, and then the flue gas is submitted to the for heat recovery. And the bottom ash, after the bottom ash is discharged, and it is the big particles or the middle-sized particles is recirculated back, and then used as better materials to maintain the temperature inside the furnace. And the big particles was discharged here. And the waste is pre-treated. In order to use circulating fluidized bed incinerator, the waste must be shredded and to reduce its particle size and to make the waste more uniform and more uniform in the moisture and more uniform in the heating values. And so because for the circulating fluidized bed, the incineration strength or the intensity of the heat and mass transfer inside the incinerators is much stronger than that in the grid. So the particle size has to be reduced to make the incineration more uniform and more well. And another technology is rotary kiln incinerators. Rotary kiln is an incinerator used for the in China. It's widely used for the hazardous waste. Hazardous waste is like the waste is discharged from the metros or discharged from the some special industrial companies. And after the waste is subjected inside into the rotary kiln, it is rotating and it is paralyzed and burned. And the unburned flue gas is burned out in the secondary charge. So the waste comes in and partially burned, and the unburned part is burned inside the unburned syngas is burned in the second combustion chamber, and the bottom ash is burned out in this rotary grate here. So it's three different incineration technology: moving grader, circulating fluidized bed, and the rotary kiln, which is suitable for different waste. And all these technologies are well commercialized in China. We have many plants is using this incineration technology in China. And sorry for the big noise. Okay. Let's close. So here is a waste incinerator using moving grader. You can see the flame, which was captured by myself in a plant close to our university. And you can see the waste is piled up on the moving grader and then it is burned out. And this is a picture on the side. Here you can see the picture of the waste which is piled up in the pit. And you can use the crab to for the feeding. And after the waste is feeding inside the furnace, and or inside the furnace, and it's piled up on the moving grader. And then it is drying, paralyzed, and gasified, and in this secondary chambers, and the bottom ash is burned out on the final stage of this moving grader. And after burning, the bottom ash is discharged up is discharged into a water-cooled bottom ash collectors. And after cooling, the bottom ash is submitted for the material recovery. And the ferrous and the non-ferrous metals or the glasses can be good from the bottom ash. And then the flue gas is submitted for is induced by the induced fan for the heat recovery to generate steam and electricity. Here you can see what was happening on a moving grade incinerators. You can see after the waste is fitted in, it will induce the drying and the pyrolysis and partially combustion, and then the fixed carbon burned out. Some volatiles will be burned out with the secondary air. The primary air is submitted from the bottom of the moving grader. there was very small holes, and the primary air is injected through these holes inside the furnace, and then secondary air is injected through the frontal and the rear walls, and with the secondary air, the flue gas is burned out, and then you can get very high temperature. It's approximately 950 degrees. The flue gas will be used for heat recovery. And here is the distribution of the gas species, including carbon dioxide, carbon monoxide, and oxygen, and also the volatiles, especially volatiles. And when the waste was running under the heating of the flue gas under the flame, it will be paralyzed. A lot of the volatiles will be devolarized into the furnace. Here you can see the combustion of the flame. After the burning, you can get the reduced ash layer, oxygen layer, reducing layer, and the paralyzed layer, draining layer, and the new feeding layers from these structures. The waste is feeding from this area, and then after draining, it is burned out. It starts burning, and then the bottom ash is burned out from here, and then discharged at this place. This is how the waste is. What was happening of the waste inside the incinerator. And there are so many different grid technology, from the travel moving grid, horizontal. It is horizontal moving grid to the counter direction pushing over grid, and also reverse acting grid or reciprocating moving grid. The waste is pushing upside, not forward, but backward. And also we have rotary drum grid, and the waste, after the waste is fed in, it is rolling down and then burned out. This is for typical grid incinerator design. And in next few slides, I would like to give a brief introduction about this different moving grid technology. And also I would like to share you several cases about the plant using moving grid technology. And here you can see it's very old chain grid stokers, and it's like a chain, and it's forward moving. It's like a horizontal moving grid, but it's using a chain as the grid. And you can see the waste is fed fed here, and after the chain is moving forward, and this is burned out, and the primary air is fed in from the bottom. From this bottom, from here, you can see the air is injected from here, and this is the chain which is inside here. The waste is fed from this part, and after incinerating, the bottom ash is discharged from this place. Bottom ash is discharged from. For this design, it is widely used for the mixed waste with some with biomass or some with coolers, which the capacity of this chain moving grid is relatively so, like 10 or 20 tons per day. It's a small designs, and especially it's widely used in China, especially in some rural area or rural cities. And another is vibrating grid. You can see the waste is the grid is vibrating. It is widely used for the biomass like rice husks and for similarly biomass burning out. And after the vibrating, the waste is the mixing of the waste with the primary air can be enhanced, and then the waste is burned out. And in China, we have like 20 or 30 biomass plant, and the waste plant is using this vibrating grid technology. And also another very special design is the rotary grid stokers. And you can see the stoker is rotating, and there are some small holes. The primary air is coming out from this small holes for burn out for the buildings. And another grid technology is reciprocating grid, and the waste is moving from the back, and the waste incinerator grid is moving forward and backward, and then it can be separated into several stages. And currently the technology from mapping and from the sample quanta or mapping is using this technology. And here is the grid structure of the grid pieces. You can see this is a moving grid. It is moving forward and backward, and the air is injected from this small holes. And we also have the grid is fixed. It is not moving, and the movable grid. And after moving, the waste piled up on this grid was moved forward, and then it is heated up and start drying and burning out. The moving distance of this technology is controlled between 30 to 100 millimeters, and it's moving very slowly, 1 to 5 times per minute, and the thickness of the waste on the moving grid is over like 500 millimeters. Sometimes it could reach 1 meter high, and a lot of the waste was piled up. And also ventilation areas. The grid ventilation areas is very important parameters, which is calculated by the area of these small holes by the cross section of this moving grid. And you can see the picture of the water-cooled reciprocating moving grid provided by the company of a Germany company, which is Martin company. And you can find this information from their website. And you can see this is pipes. It's water-cooled pipes. Inside of the pipes, there are saturated high-pressure waters. And these waters will absorb the heat released by the municipal solid waste after incinerations. And then the steam will become the water will become the superheated steam, and then submitted for the electricity generation by a turbine. The waste is coming from here. It is fed inside of the incinerator from here, and then it start burning out. And then this is inclined reciprocating moving grid. You can see the waste is the grid is moving from the backward to the forward, and waste is coming from this side. And after waste coming out, it's rolling down, and the moving grid will push the high temperature ash to help the drying of the fresh feeded municipal solid waste, and then help its burn out. And here is the place where the gas discharged. You can see the waste coming down, and then burning and burn out, and then unburned residue is rolling down to the discharge part. And here is, you can see from this picture, you can see very clearly, this is the refractory materials. Unlike this one, here is the water steam pipe. Here is the refractory walls. When the refractory wall was used, the heating value of the waste is relatively lower than the incinerator using these water steam pipes. Because in order to help the burnout or maintain the temperature inside of the incinerator, we want to reduce the heat absorbed by the steam. So you cover the water pipe used by the refractory materials to maintain the temperature inside of the furnace. And moving grid, we also have different design of the furnace structure. You can see here 3 different designs. For this counter flow types, the waste is moving from this direction, and the flue gas is moving from this direction. This type of design was used for low quality waste, usually for the municipal solid waste with heating value lower than 7 megajoule per kilogram. And when after the heating value of the waste is increasing, for example, the food waste is reduced or the moisture of the waste is reduced, when the heating value was increasing, like the waste in developed countries or the waste in the Shanghai or Peking, where the economic is relatively good. And we will use the cross flow types. The waste is feeding from directly, and the flow gas is from this one. And this is like a cross flow type of the design. And if the value of the waste is still increasing, we will use the uniflow type of the design of the moving grid. You can see the moving direction of the waste and the moving direction of the flue gas is in same. This design is used for very high heating value waste. For the waste is a heating value higher than 12 megajoules per kilogram. And sometimes in order to enhance the mixture of the flue gas with the waste, we will put a structure here to enhance, which can be used for the stable combustion and also for enhanced mixture and to reduce the nitrogen oxide and dioxide to make the incineration more reliable. And in this picture, you can see as I have introduced, this is how the reverse reciprocating grid was moving, which was provided by the Martin companies. And this technology is very widely used. Approximately 30% of the moving grid in China is using this technology. And you can see the waste or the bottom ash is pushing forward, and the waste is rolling down to the rear part of the moving grid. And then the hot, high temperature ash is mixed with fresh municipal solid waste to help its drying and to help its ignition and catch fire. And another technology is rotary cleaning, as I have introduced. The waste is coming from this side. And here is the hole for the burners for ignition of this, for starting up of the furnace. And also this part, there will be burners burning natural gas or the oils to help the startup of the furnace. Now, after the temperature inside of the furnace is over 850 degrees, the waste will be fed in. And then after the waste is fed in, it will rotary to the back of this waste. And here you can see the hose, which was used for the primary air to come in. And the capacity of the rotary grid can be ranging from 7 to 40 tons per hour, which is it's approximately largest capacity is over 1,000 tons per day, which can be served for a city with 1 million people. And then in the following several slides, I would like to introduce several typical grid stock providers from the Martin, from the North, and also several companies like New Centuries from local companies in China. Martin is from the Germany is the largest moving grid providers in the world, and their technology has been widely used globally, and especially in Europeans and also in China. As I have mentioned, approximately 30% of the moving grid are using the licensed technology. Yeah, you can see this is a water-cooled moving grid. Horizontal, it is horizontal reciprocating moving grid. Sorry. And you can see very clearly how this grid is laid out, and it is unit. For each unit, this is one modular and also another modular. The capacity of each modular is approximately 300 tons per day. So the overall capacity is approximately 600 tons, and then it is used for burning very high heating value waste. You can see it is a cross flow type designs. From here you can see. And this is a great pictures and how it is. This is a fixture and this is moving. And the air is coming out from here. And this moving grid is forward and backward. And then the waste is pushing forward and burned out. And here you can see, as I have mentioned, it is water cooled. So the cooling water comes in and then comes out. comes out from here. And after, why we are using water cooler? Because if you are burning very high temperature waste, the temperature of these grade materials must be contained lower than 450 degrees. So we have to use the water cooler. Otherwise, it can be broken after several years or 2 or 3 years usage. And another is, or you have more inclined, it is reverse moving reciprocating grade. And 1, 2, 3, 4, 5 unit. The capacity of this is 700. Each modular, you can see here, each module, the capacity of each modular is probably 150 tons per day. So the overall capacity is approximately 750 tons for the treatment. And this is how the air is coming out from the hose, small hose, ventilation hose, and also the moving directions. And several units. Here is a 6 unit. You can see it's each unit can be constructed very quickly, and it is modularized. Very easy. You can build a moving crate, such a moving crate incinerator very quickly. And 2 workers, maybe 1 week, you can finish the construction of these moving crate incinerators. And the cylinders, which was used to push the waste and push the moving crate. Here you can see how the waste reciprocating moving crate is used for the low ideas for the waste in the air, with high moisture waste. And several cities are using this technology in Jiangsu, like Chongqing. Chongqing, which is getting the license from the market, and they're using this technology. They have 2 incinerators. Each incinerator was with a capacity of 600 tons per day. And you can see the waste, the received waste. Here is the waste received. After we got the waste in China, because it contains relatively high moisture, so the waste is put in the pit for a few days, and then the will be reduced from 40 to 25%, and approximately 15 to 20% of the leach out is discharged from the pit. And then the heating value of the waste can reach 7 megajoules per kilogram. Then this waste is submitted for the incinerator for burning. After burning, we can get approximately 60 tons of steam per hour, and this steam will be used for generate 24 megawatts of electricity, and this electricity will be used for local residents. And another technology, and also from the Europeans, was from Denmark, Poland. And it's also providing the moving grid with water cooled. This is water cooled design and non-water cooled designs. And you can see here it was used high calorific waste, which is up to 25 megajoules per kilograms. And the cooled water comes in, and after cooling, the high temperature saturated water comes out. And this saturated water is also submitted for the superheated steam generation. You can see the design of this foreign air-cooled moving grid is different. The size and the shape of this moving grid from different countries usually are totally different, especially for the ventilation hose. You can see here the hose area and the hose size and the shape was different from the different companies. But all this hose was used for the primary air, and all primary air is induced or in subject into the primary air from the bottom of this moving grid. This is water cooled one. And here is they also provided for the vibrating grid. You can see it is vibrating, and when the waste is or the biomass is powered up on the surface of this moving grid, it's vibrating, hopping to forward, and then after hopping, the air is well mixed with with the materials on all the waste on the surface of the moving grid and burned up completely. And here you can see a typical design used for the packed biomass incineration. And you can see the packed waste is shredded and feeded into through a screw feeders, and then it is caught fire and burned out, and then the superheated steam was generated for electricity. From here you can see the temperature when was burning a biomass. The temperature is much higher. Of the steam temperature is much higher, is approximately 150 degrees higher than that generated from the municipal solid waste incinerators. Because when the municipal solid waste was burning, the waste contained a very high concentration of the chlorines. Chlorines can cause very serious corrosion problems if the steam temperature is over 500 centigrade degrees. So usually the temperature of this was relatively low. And another technology also widely also from the European is Steinmüller's technology. Steinmüller's also, this technology is widely used in Ningbo and Shanghai with very high capacities. It's a staged moving grid design. You can see it has 3 stages. And you can, this is pictured taken by myself inside the incinerator using Steinmüller's technology in Ningbo cities. You can see after several years usage, the moving grid is become broken and it's have to be rechanged. And if the moving grid is not well operated, you can see some of the waste is well burned, but some part of the waste was not well burned. So the organic fractions contained inside the bottom ash would be relatively high. In China, according to our national standard, the unburned carbon content in the bottom ash should be lower than 3%. But for this plant, you can see as a lot of the waste was not well mixed with the air. The burning ratio is relatively low. So the organic or the carbon content in the bottom ash sometimes can reach 5 or 10%. It's very high. And here you can see the cross section of this plant. It's waste is piled up, and then it's fed inside the furnace and then burned out. You can see the layout of the heat exchanger. It's horizontal layout. So the ash deposited on the surface of these exchangers can be well collected at the bottom. So it can be collected here, and then the collected bottom ash can be submitted for the landfilling or for the sanitary treatment, because it is classified as the hazardous waste. And this, after the heat exchanging, the dirty flue gas is treated with a scrubber and the baghouse and the lime and active carbon injection unit. And for the active carbon is used for the dioxins and also volatile heavy metals adsorption. So. And another technology is SIGAS, which is also well used in China and several cities in the Shenzhen and several cities in the Jiangsu. And this technology is also licensed to several companies in China, including Everbright. And they have to do some improvement of this technology, and then to make this technology suitable for the West in China. And then, for this design, the moving grid is moved forward, backward, and also it is like up and down. So it's not only horizontal motion, but also vertical motions to help the mix of the waste with the primary air, and also to help the burnout. So by using this technology, the burnout ratio of this of the municipal solid waste is pretty much higher, and the carbons contained in the bottom ash can be lower than 1 or 0.5%. And in China, we also have similar technology, which was imported from Japan. Very similar to the technology from Europeans. It's also staged like a staged moving grid technology, and they also have, in order to enhance the mixture, there will be some distance from the two stages. After when the when the waste is rolling down, it will mixed, and then it can be help the burn out of this waste. And here you can see this technology, how it can be used for waste incinerations, and also several plants in the Japan, especially the plant in the Tokyo, 1,800 tons per day, which is using this Takuma technology. And another worldwide is a technology from the Hitachi Zosan. It's using the Voros technology. Voros moving grid, but the Hitachi Zosan's incineration technology. And it's very similar. The waste is received and feed inside the furnace, and the flue gas is used for heat exchange. But their moving grid is a little bit different by control the extra airs and also the recirculating of the flue gas. And this is a plant located using this technology located in the Dublin, which was put into operating in 2016. And I visited this plant in 2017, and you can see it's very 2,000 tons per day, and they are using the technology provided by Hitachi Zosan. And by using their technology, the excessive air ratio is much lower than other technology. It is ranging from 1.3 to 1.5. For other technology, usually the excess air ratio is exceeded 1.6 to 1.7. So if the volume of the flue gas is reduced, the overall heat recovery efficiency can be increased. And the more you can see here, the boiler efficiency reached 90%. Usually, the boiler efficiency is ranging from 80 to 85%. But for their technology, it can reach 90% by reducing the excess air ratios. And also, the more electricity can be generated after the boiler efficiency is improved. This is a moving grid that they are used. Another technology widely used in China is provided by the JFE, Japan Holding Steel Corporation. They are using the super reciprocating grid. And similarly to the design, similarly to the idea of the Hitachi Zosan, they also reduce the excessive air ratio to 1.32. And also they are doing the high temperature secondary air injection and also the recirculating of the flue gas. By combining all this technology together, they not only can reduce the excessive air ratio, but also they reduce the concentration of the nitrogen oxide. The original concentration of the nitrogen oxide can be reduced to 50 ppm, which is much lower to comparing to other technology. Usually, the nitrogen oxide concentration released from the waste incinerators is ranging from 300 to 400 ppm. And then you have to use SCN or SCR or SNCR to take care of these special acid gases. And in China, we also have two local companies like New Century, which is located also in Hangzhou cities. They got the license from the Martin, and then they do some redevelopment, and then put another stage at the bottom of this moving grid. And this is a reverse in moving grid, and this is the forward moving grid. So they combined this reverse moving and forward moving grid together to help the burnout of the low quality municipal solid waste. So they can burn the waste with very much lower heating values, like 4 to 3.6 to 4 megajoules per kilogram of the waste. The feeding waste can reach 40 to 45%, almost half of the waste was moist. So by using these two-stage designs, they can also burn very well. And I also still have several minutes. I would like to give a very brief introduction of the systems. And we have introduced the moving grid technology, and also now you can see the whole systems for a plant. for one waste to energy unit. You can see here is the reception hose. Waste is traveled through by the trunk and to this hose, and then fitted into the bunker or the pit. And then the crane was used for the feeding to the hoppers, and then it is pushed into the incinerator. And then after burning, the high temperature flue gas is cooled down by the boilers through the exchangers, and then it is subject to the APC systems. And the ash the bottom ash is discharged here, fly ash is collected here, and the induced fan is working here to induce the flow, clean the flue gas to the stackers. And for each waste incineration systems, we need a backup filters to collect the very fine particles. And here is the pictures how we do calculations. For example, how many electricity or how many superheated steams we can generate by burning the waste. And the horizontal axis is the waste, and the vertical or is the thermal output, the input and the output. And here different these blue lines was representing the different waste thermal efficiency. So it is typically ranging from 65 to 82%, I have mentioned. And during we are building our waste incineration systems, we also need to calculate the mass balance. From here is how much heat we can recover. And from this picture, you can see how the waste is participated inside of this incineration system. How much leakage, how much bottom ash, how much fly ash, and how much flue gas is generated, and also how much steam can be generated. And by using this mass balance, you can see the whole materials, how it is distributed inside of the systems. And after mass balance, we also need to calculate the energy balance. The energy balance is calculating how many electricity, how many superheated is generated, and how many heat is wasted by the flue gas discharged through the stack by the bottom ash and it is used to calculate how much electricity is consumed by the system itself. We got much electricity generated, but some 10 to 15% of this electricity is used by the incineration system itself for the feeding, for the moving of grid, and for the induced fan and bottom ash discharges. And also, in order to calculate how much electricity can be generated through the Rankine cycles, we also have to do the thermodynamic calculations. By using these calculations, we can see the boiler efficiency and how many electricity, how many superheated steams can be used for electricity generation. And in addition to this mass balance, energy balance, and the thermodynamic balance calculations, we also, another very important is combustion control systems. Here you can see we use a lot of the monitor, temperature monitor, pressure monitor, and also mass flow sensors to do the system monitors. And also we use distributed control systems to running the whole plant. Usually for the in the Dublin, the whole system can be run all by itself. So the only thing you need to see is for the operators is only to take care of the feeding and take care of the bottom ash. The whole system can be run by itself. This is combustion plant. I only have a few very limited times, so I would like to move forward. This is air pollution control systems. And after the flue gas is generated, it will be used acid scrubber alkalines to remove acid pollutant species contained in the flue gas, especially chlorines, hydrogen chlorines. And also we use the active the carbons to take care of the dioxin and the pH and the heavy metals. This is another semi-dry systems and also dry systems. And also we use backhouse for the particle remove to also ESP for the electricity removal systems for very fine particles to take care of the very fine particles contained in the flue gas. And also for the bigger particles, sometimes you use cyclones, especially for the circulating fluidized bed incinerators. We use cyclones for remove the high density particles contained in the flue gas. The acid gas systems, acid gas scrubber, wet scrubber, and also packed towels, which is help to the moisture and the flue gas exchanging to improve the acid gas removal efficiency. And nitrogen oxide removes. And also catalytic nitrogen oxide removing systems. Here we use the catalysts and also use the coolants help to reduce the nitrogen oxide to nitrogen. The bottom ash discharge unit to collect the bottom ash and for the materials or ferrous materials, non-ferrous materials recovery. So here you have several pictures and several cases. I would like to move to very quickly and several plants information worldwide. And I would like to show the plant which is located in Hangzhou cities. And here, this is the plant in Ningbo SUS, which is very more fancy and modern. This is plant designed by a French designer, and you can see it's like a honeycomb and a very beautiful plant. This is the layout of the technology used by this plant. You can see here we have 9 units to take care of the flue gas contained to make the emission of all pollutants very, very low, much, much lower than our national standard. For example, for the dioxin, the national standard was 0.1. For this plant, it's 0.01. It's very, very low. This technology is using the boron technology, which is supplied by Hitachi Zosan. And another, okay, so very quickly, several conclusions about moving grid incineration technology, and it is a very suitable technology for burning waste with different heating values from 4 to 20 joules per kilograms, and you do not need to do pre-treatment. It can be operated over 8,000 hours per year, and the capacity of this technology can range in 1,100 to 1,000 tons per day, and very suitable for large-scale waste treatment. And due to the limited times, and several slides I didn't give time to the especially close cases, and I will share these materials to all students. And if you have any problem, or if you have any questions, and we can discuss after this training workshop. And if you need some more information not included inside of these materials, you can send me emails that we can discharge. And a little bit quicker and a lot of information, and I think the students may need some time to consume all these materials. That's my introduction, Reda, and thank you very much. Thank you all students for listening to this courses, and thank you very much.
Really appreciate Professor Huang. It was very, very impressive. All the work that has been done, since all the comparison technologies, and more specifically, how with the great technology, how they could burn the waste with low calorific value, and it's a very interesting. And I hope all the participants, learned, how China could succeed in managing and treating their waste, and how they advanced the technology to treat the waste that is more specific, more moisture. And I believe that the composition of the characteristics of waste of the Chinese are quite similar than North Africa. So I think there will be some similarity that need to be investigated. So
Okay.
now I'm gonna thank you so much, Professor Huang, and at the end we will of course all the participants just take notes about all your the question that you want to ask, and at the end of this workshop you will have the opportunity to ask your question. So now I will move to you're welcome. I will move to our next speaker, which is Mr. Tian, who is he's the general manager. He's the general manager of investment and development overseas business center at Everbright Environment. So I just want to make a very quick introduction that Everbright Environment is one of the largest waste to energy developer in China, with 499 environmental protection projects, with an aggregate investment of approximately 23 billion. Was, as I say, was one of the largest waste to energy investors and operator, and it had a total of 168 waste to energy projects with an aggregated designed daily household waste processing capacity of 144,650 tons. And also, Everbright is one of the strategic partner of the International Coalition of Green Development on the Belt and Road under the United Nations Environmental Program, and the global convener of the theme of green technology innovation and corporate social responsibility. And also, China, Everbright Environment was invited, to promote the formulation of standards of the waste energy project of the World Bank, and they lead the formulation of the global PVP standards for the waste energy project of the United Nations. During this presentation, we're gonna hear from Mr. Tian his insight in how they implement business model for the waste to energy for the public first PPP. So, Mr. Tian, the floor is yours.
Thank you, Professor Rita, our moderator. Can everybody hear my sound and see my video and my presentation?
Yes, very good. For me, if I hear it, so everyone could hear it. Very good.
Okay, thank you again, Professor Rita, our moderator. Okay, this is Troy. My name is Troy, and I work for China Everbright Environment. And today, I'm gonna give a short presentation of today's topic, is comparison of the waste to energy project development in Asia and in Europe. The last speaker, Professor Huang, and also the speakers from yesterday, I believe their presentation is more focused on the technology part. My presentation will be focused on the partnership, the business model. So my presentation will be much simpler, and I think will be shorter. So I would like to give this heads up to the Mr. Moderator and also our next speaker, Professor Thanos. I think my presentation probably will last 30 to 40 minutes. Okay. So today's topic, as I covered briefly before, that's this comparison of two different models, WT models in Asia and in Europe. And first, I'd like to take a few minutes to cover China Everbright, basically who we are. So China Everbright Environment is owned by China Everbright Group, which is a state-owned conglomerate Chinese enterprise that covers a variety of business, that from banking, investment, insurance, and China Everbright Environment is a investment arm in the environmental infrastructure. So we help China to develop the infrastructure to take care of the municipal solid waste management, hazardous waste, wastewater treatment, and also we're also a player in this renewable energy. The company is incorporated in 1993 and is publicly traded in Hong Kong Stock Exchange. So during the past decades, company is growing pretty fast. We have achieved some I would proudly say some significant achievement in China. As of today, we have more than 14,000 employees, and our revenue in 2021 exceeding the US $6 billion. Okay, so in this solid waste management sector of the solid waste management, our business covers the full value chain of this business, starting from the investment. Also, we can do the EPC. We do a design, engineering, and construction plans, and also in the downstream, also do the operating and maintenance of the plant. If you can see my mouse, these pictures down here. The first one is during the design phase. We help our clients, mostly in China, it's the government, it's the local government of Chinese municipality, to design the plans. And the picture in the middle is some of the core equipment, or we call moving grade incinerator, that we are able to design and manufacture ourselves. And the picture on the right is during that maintenance and operation phase. We have engineers to help, not just for our own plants, but also for our clients to inspect and provide maintenance service for their plants. Okay, I hear some like interference. Okay, now it's gone. It's not from my end. I'm alone. Okay, so the next slide is present our global presence of China Everbright Environment. Our core business, I would say 90% of business is still focused in mainland China. When we just started, we started from the east coast of China, and during the last decades, we actually moved our business from the east coast to the west coast. This east coast of China is more considered more developed part of China, and the west part is less developed. So this strategy really helps us to grow, because we first started in a more developed region, and that project, when it's a success, it has more, I would say, social impact to the reputation of the company. So when we try to build another plant in the less development region, it's easier. So that's also one of the factors contribute to our success expansion in China in the last 10 years. As of today, as in 2022, we have developed more than 200 projects in the solid waste management sectors. In wastewater treatment, we also have about 150 projects. In green tech, that's what we call to treat the agriculture and forest waste and some hazardous waste, and also in this renewable energy area, that we have 140 projects. So in total, we have developed more than 500 projects during the course of the development of the company. Not just in China, we also have achieved some humble success in outside China mainland, that including 4 countries and regions. The very first one is in Germany. In 2021, we acquired a small, during that time, I would say it's medium-sized photovoltaic project in Germany that's close to Berlin. At a capacity of that project is around 4 megawatts. And also then neighboring Germany, in Poland, in 2016, it's also again another M&A project. We acquired one of the leading waste management company in Poland, but they are not using the waste incineration technology. They're using more, I would say, more mainstream technology that used in Europe. That is called MBT, mechanical biological treatment of waste. And in the same year, we also successfully developed one of our first waste management project using incineration technology outside China. And that one is located in Vietnam, in Canton City. And that will be one of our case studies today. So I'll go in more details about this project. And also in 2021, in our water business, we won a contract to provide the operation and maintenance service in in the Mauritius country. So the next slide is just listed the 4 international projects we have developed in the past. This first one we call Canto WT project. This is first the WT project we successfully developed outside mainland China. And then the second one, the one based in Poland, the company is called Novago. So that's we acquired this product in 2016. The value of the transaction amounts to 123 million euro. And the third one is the small solar farm project located in the Zhuoli, a small town close to Berlin, in Germany. And that's also the earliest project we developed outside China, which was in 2011. And the latest one success we had is in the Mauritius. That is the wastewater treatment plant, treatment project. We didn't develop the plan for them. We actually provide our expertise in operation and maintenance and provide such a service to this plant. Okay, these numbers, I just want to go through this give you an idea like what the capacity of China Everbright Environment. This is only in the solid waste management sector of our business. And in this sector, we almost exclusively using the waste incineration technology. So this number, I would say this number probably position us not just in China as the largest investor and operator of WT plant, but also in the world. So so far we have 153 projects, as I mentioned before, and that translates a daily waste processing capacity of almost 140 tons per day. And within this number, because some of them are still under development, this number within this number we have almost 114,000 tons of the processing capacity that is in operation. And the next few slides, I'd like to highlight some of our WT projects we successfully developed in the past that has very positive social impacts for the local community and in the industry wide as well. The first project I would like to show you is Changzhou. It's one of our first project we developed in China. It's located in Changzhou city. It's also a medium-sized city in China, boasts a population of about 5 million. The significance of this project is about its location. Its location is pretty close to the city center. It's maybe like a few hundred meters to the city center, and also surrounded by other residential areas. The significance of this project I'd like to highlight is that this really emphasizes our commitment to develop a safe and environment-friendly WT project that we use to process the waste. Of course, during the course of the development, we received some protesting from the citizens for placing such a environmental infrastructure close to the place they live. But during the past 17 years, during the operation, there's no accident. And all our emissions compliance with most stringent emission standard used in the world, and also the architecture, the landscape of the plant is also friendly. So people actually now they don't really mind. They have such a plant close to the place they live, and also our business model that we actually we open to public. So we encourage people to come to visit our plants. We have some landscape close to the plant. It's like a garden. So during the weekend or even weekdays, the people can come in and to have some, their fun time within the plan. So that's really help us to build a good relationship with the local neighborhood and with the local government. So that's Changzhou plans. The next one I'd like to highlight is called Hangzhou plan. It's also one of the largest plans we developed in past. The capacity of this plan, I believe, is more than 3,000 tons per day. That translates to 1 million tons per year. And we also implement very high standard in this plan. I believe the air pollution control here we used here is more stringent and more strict. It's more strict than the currently imposed in used European standard, this 2010 standard. So this Changzhou plans, Hangzhou, another city. This is the major city in China. I think they have a population close to 10 million. So the next highlights I like to present to you is another WT plans we developed for another mega city in China. The city is called Suzhou. I think it's close to Shanghai. So this city has a population more than 10 million again. And also this is one of the largest plans we ever developed. The plans both phased actually. The first one, phase 1, phase 2, phase 3 combined. I think this is due to the growing demand of the city, that because the population is growing and also economy is growing, the waste generation in that city is also growing pretty fast. So during that phase 2, phase 3, during the very first phase, the capacity cannot meet the requirement of the demand. So at the request of the government, we expand this plan into phase 2 and into phase 3. I think now they have combined capacity of 3,500 tons per day. And also the latest development of this plan is again, because still the demand is growing. I think the government would like to actually even increase the demand, increase capacity of the plan even more. So now our latest plan is to build another phase 4, but phase 4 actually will be much bigger than phase 1, 2, or 3. It actually will replace phase 1, 2, 3. It will be have new plans designed and constructed in the project sites. So that's the information I'd like to share about the Suzhou plans. Another one our flagship project we developed for China. This one is another WT plans we plan to build in the next, say, 2 to 3 years. Because as some of you may have heard, in 2020, I believe in 2020, Chinese government, the central government, have laid out a very ambitious plan to build another economical zone that is close to the capital city of Beijing, and this place is called Huang. So, of course, in such an ambitious plan, waste management is an indispensable part of that plan. So we also will develop a state-of-the-art using the most advanced technology WT plans for this region. It's not just focus on the solid waste management using the incineration technologies. We also cover other waste management needs, including this how to treat the sludge from wastewater treatment, and also how to treat the ashes from incineration, and food and kitchen waste that we use a different technology, not using incineration, but using AD, what we call the anaerobic digestion, and also the medical waste. And that's basically a pretty comprehensive waste treatment facility for this special region. So maybe in the next 1 to 3 years, we'll be happy to share the latest news about the latest development of this plan. Okay, here the slides highlights some of our achievement recognitions we obtained for the company because we are a Hong Kong, sorry, a listed Hong Kong stock exchange company. We actually are proudly be included in some of the key indexes in the world. Some of the many, I would say, most influential index, including the Dow Jones index, also the S&P Global Index, and the Financial Times, and also the MSCI China Index. That really emphasize our achievement and commitment to help China and the world to protect the environment, to manage the waste in a safe, efficient, and a sustainable way. Okay, so the next slide. Okay, now I'm gonna go through the case study parts. I'm gonna give you two examples to compare how the WTE business, or say in general term, this waste management business is different, how they are different in two distinctive regions. One is a developing economy. I think that applies to China, Southeast Asia, and North Africa. Another example I would like to give to you is a developed economy. I'll use the European Union, EU, as example. So why did we choose Southeast Asia and EU? It's because how this actually we China Everbright developed the two projects in these two regions. So I would say using these two regions give you a hands-on, a real experience. I can share the real experience with you how this business model is different in these two regions. So in general, so in a developing economy, say in Southeast Asia, the WTE activities is pretty active. You know, people are still very interested in using this technology to treat the waste. I think one of the contributing factor is that in that region, the waste management is not regulated very well, and most of the I wouldn't say most, but I would say a good portion of waste is illegally dumped in the landfill. So that causing some serious environment impact, not just to environment and also to the people there. So I think there's a high demand to find technologies that is better than landfill to treat that waste. That's how the WTE technology comes in. However, in compared this to EU, WTE is not that active because EU is a pioneer to design and implement WTE technology to treat their waste, but not recently, in the past 40 years ago. So they are very early on that. So as of today, this WTE utilization has, I would say, saturated. It's also highly developed, leaving no much room for further development in this WTE technologies. Another reason is because EU is also shifted their waste management strategy. Again, not recently, 10 years ago, maybe 15 years ago, they encouraged to reuse, recycle, and reduce the waste. So that's another reason why WTE does not have such an active role in EU as compared to Southeast Asia. Okay, another characteristics of WTE technologies in developing economy is that this development, such a development usually receive very generous support from the government to have subsidies and to help these developers to really profit in this project. Again, this is in EU. You cannot expect such a subsidy and support from the public parties, for example, government, because now they have been built already. They are there. So nowadays, if you want to develop a WTE plans in EU, you are basically on your own, or it's a private party. So all this development fund will come from the private party. So that's another another differences between these two regions. And when you say private parties, then there's no subsidies, and also there's no so-called guaranteed gate fee or no subsidies in the power generated. So everything is market driven. Everything is market price. They are highly variable and highly volatile. So that's in EU. I would say this also applies to other development regions, economies, Australia, New Zealand, and North America. Okay. The third part, another the point 3, another very distinctive point in developing those WTE facilities in EU and in developing country is the cost. So the development costs in a development costs in a developed economy of a WTE project, a WTE plant, such for example EU, is usually multiple times higher than that in a developing economy. So all this point I just briefly covered will be go to in details in the next few slides. Okay, first I would like to present to you that's the plants that I mentioned before, the Canto plant that is located in Vietnam that China Everbright developed in 2016. So that's how it looks like. The capacity of this plant is about 400 tons per day. That is translated to more than 100,000 tons per year. And this power generation capacity of this plant is about 7.5 megawatts. Okay, this slide gives you a quick understanding, a quick view of how the business model is for this plant. It's actually quite similar to other plants we developed in China. This one we call this the PPP, the public-private partnership, and this specialized model is called BOO, build, operate, and own. You know, this is fit in this umbrella term of PPP partnership. So basically, we have a partnership of the Canto government, the local government. They have a demand to build such a plant to help them to manage the waste, solid waste for that city. So that's where it comes in. Okay, we can help you to build that plant, and we can go and invest money to invest money and also operate in the plant after it's built. So that's how the partnership looks like between us and the government. So what is government can do? First, they will provide the land. In this case, it's not completely for free. I think it's for free for the first 15 years, and then they will charge a land rent. But that land rent, that's really insignificant cost during that entire cost of the plant. So it's not really important. The rental could be very low, negligible, I would say. So another important role of the government is they have to provide waste to the plant. Also, they need to guarantee the gate fee, and that's the Canto government. And then that's one part, I would say one very important part of the portion of the revenue that comes from gate fee and guaranteed by the local government. And the second portion of the revenues comes from the power generation. That's by burning the waste, we produce energy. That is also have support from the government, but this is not from the local government, not from this Canto government, but through a state-owned energy companies by the Vietnam government. I think it's called Y-South company. So the government, the central government, I don't know if that's called central government, but that's the national government of the Vietnam. They actually have a subsidies to for companies in this business that's producing energy from the waste. So they will guarantee price of the energy you produce. They will buy that with that fixed price, and that's another very important portion of that revenue. And this price is actually much more favorable than the market price of the energy in Vietnam. So that's incentivize company like us to build the plants to treat waste and generate the power. Because the power price is very good. It's much more favorable than the coal-fired price. And in this way, you know, they incentivize companies in these areas to build more plants to treat waste. So that's how this business model looks like for this plant. And of course, we also have our own contractors for EPC contractors and operation maintenance things. Pretty similar to what we have in China. Okay, so that's a small breakdown details of how this business model looks like. As I said, this is umbrella term is called PPP, but the specific contract form is called BOO. This build, operate, and own. So, for in the first 25 years, give or take 22 years. I'm sorry, this is 22 years. We don't own, China Everbright don't own this plant. The government owns this plant. We just help the government to build and operate the plant, but we are entitled to receive the revenues generated by this plant, but of course also bear the cost. But then after 22 years, then we'll become owner of this plant. The government will transfer the rights of the plant to us. So that's what they call this BOO contract. And as I mentioned, the local government is responsible for providing the waste to the plant. So they will collect and transport the waste to the plant. And also they will pay us for each ton of the waste we processed in the plant. The gate fee is guaranteed to have a floor price for the gate fee, and it's adjustable according to each year's CPI. And the power price is also fixed. I think this subsidies is actually by this Ministry Industry Trade of Vietnam. I believe this is the government organization. So that's not from local government, but from the higher level of the government of Vietnam. And then the land, I just mentioned the land. Land is basically free for the first 14 years. After that, we'll charge a rent for the use of the land. But as I said before, the cost will be symbolic, very insignificant, during that entire development of this plant. Okay, this gives you what would you expect it to build a plant to build a plant. So basically, you need a few licenses from the government and from the environment permits, land permits, to building permits, and other permits. So this is again for this Kanto product in Vietnam, but it's again pretty similar to what we have, the Chinese model that we had in China. So if the government is very committed to build such a plan for their people, then the whole process is not really would not take that long. So I think take this Kanto as example, the entire process is just more than a few years. So that's very efficient, I would say. I will go through this part. I'll compare this part to EU part later, and you will see how EU is how they are different from this process. They take much longer time, not just because they have more their legislation are more strict and different, because also such a plant, such an environmental infrastructure in EU, they are subject to more scrutinized inspections. So that will also contribute to a much longer development time for EU, mostly in the obtaining of the relevant license for such a plants. Okay, here on this table on the left, you can see this time some of the very important milestones which we achieved for developing this Canto plant. And from the contract signing to this completion of the plant, which means it's entered into operation, that took about, I would say, more 2 years. That's actually in line with the development period for such a plant in China. Of course, I would contribute to the smooth development, to the cooperation of the local people, and also the support from the local government and also from the central government. And that's the construction phase of the plants. The entire construction, I believe, takes a little bit more than, I think, a little bit less than 2 years. Again, that's in line with our construction period to construct and building such a plant in China. Again, I will go through this part later. For EU usually requires much longer construction period, probably up to 2 years. That's again, that's due to their different legislation. The labor law is different. They don't really allow to work overtime, and also they have very different standard for the construction. So you have to apply different standard here and there, and in general they have more strict construction standard. So that also requiring longer time to build similar plants. And here, this slide here is highlights, not highlights, but give you a concept, idea, basic understanding of how the technology we use for the Canto plant. I will not go through in details because the other speakers, such as Mr. Huang has go to in deep depth to give you a lecture about how incineration technology works to treat the waste. So here is just a section view of our plant. So the waste truck comes in here and they unload waste into our bunker. I think in Canto and in China, usually it takes up to 7 days of storage because the waste in China and in some Asia countries is pretty high content of moisture. So we wait up to 7 days to let all this moisture discharge. This moisture, if you put too much moisture into our incinerator, that will negatively impact the incineration efficiency. So that's why we'll wait such a long time to let the waste dry up a little bit. And once it dries up enough, we have this the scraper, and then just move the waste into the feeder and into the moving grade incinerators. And in each sections, they will burn differently until they'll turn into ash. And during that process, they produce this energy, hot energy. And we use this energy to heat up the boilers. The boilers has water inside. They heat up the boilers, produce the steam. We use the steam to push the turbine to produce the energy. So that's basically how this waste to energy process works. I think Canto and in most of other plants in China, we only produce the electricity, but in some cases we also produce the heat. We just produce the heat to the local people. Usually, such kind of business model requires the access to the local heating, the local district heating network. In the perspective of business, the heating, providing heat is wouldn't say it's much more, but it's more favored than 100% power, because from heat to power, that's another step of conversion that we're leading to the reduction of the efficiency. So you'll get much less heat from heat, process power from heat. So if you can produce heat instead of power, the efficiency is much higher, and that usually would generate higher revenue for this plant. So in that kind of arrangement we call CHP, combined power and heat. So that's kind of that's kind of technology is more favored for from the perspective of the developer, but usually because it will give a higher return of your investment. So after this, the heat had been recovered by boilers. This gas, flue gas carried by heat, will be cooled and then be discharged to the environment through a stack. And by discharging the polluted air, of course, you have to go through a series of treatment to make sure the discharged gas complies with the environmental standard. All of our China Everbright plants in China, we imposed the so-called Directive EU /75/2010 standard. That is currently in use, European standard in Europe. We use that standard to regulate our air pollution control. Okay, this slide gives you these pictures of our moving grade that used in our plant. These moving grade incinerators are designed and manufactured by China Everbright itself. I think the largest one we can produce now is approaching 750 tons per day. That's translate to about 300 tons per year. So that's pretty, I would say, pretty big. One grade give you this much of capacity, and I would say 3 grade will give you really a mega sized WT plants that's about almost 1 million tons per year of the treatment processing capacity. I believe other speakers have gone through the details of how moving grade incinerator works. So I will not cover this part in this slide. Okay, here you see this column here. That's how a typical flue gas treatment unit looks like. So flue gas will go through this back filters and other process until they are clean enough to be discharged to the environment. Again, here is an example of the Canto plants that we developed for Vietnam. The local regulation is on this column. It's called the QCVN 161-MT. And it's pretty, I would say, not as strict as the other standard used in the world and the standard we used in the China Everbright WT plant. So that we use this standard. You can see it's much more strict than the local Vietnamese standard. Of course, this all depends on your need. Usually we use that standard for our own plant because people have a concern about the environment. But if it's not necessary for other developers to be compliant with such more strict standard, because lower the emission standard, lower the cost. So if we don't oblige to be compliant with such a stringent plant, we would prefer to a much looser emission control that will help us to lower the development cost. Okay. Actually, also again, I'll cover this part later. This standard, although it's called EU, but most EU countries, most latest WT plans to be developed in EU region, this one is obsolete. It doesn't up to date. They have a new standard coming in force very soon. So the new plans that is to be developed in EU region, they will use what they call BAT standard. That will be much more stringent than this currently used standard. I will go to that part later, but unfortunately, that BAT plans would definitely increase the not just the development cost of the plant, but also this operation cost. Okay, this is another part of how to manage a plant in terms of the leachate. As I said before, this is applied to Vietnam and also other Chinese WTE plants. It's because the waste, the characteristic waste in China and Southeast Asia, they tends to have very high content of moisture. So during that storage, they will produce a high amount of highly contaminated wastewater. It looks like this one. So you cannot just, you must have a way to treat them. The amount is too much to be, to be put into the incinerator itself. If the amount is small, you can just spray that into your incinerator. So that high temperature will vaporize everything. They will take care of that. But if the amount is this high, you cannot. Well, it will damage your incinerator, I would say, to put that much of moisture into that into your incinerator. So we have to develop a dedicated wastewater treatment unit to treat this leachate. It's not really that different from a typical waste treatment plant. It's just smaller scale. We'll go through a different process after this. Eventually, they call this RO, this reverse osmosis. The water effluent is really clean. So in China Everbright plant and also in Kanto plant, our objective and also our practice is to fully treat it. All this leachate produced in the waste, and also we fully recycle this waste, put them into plant use, and also we do an additional filtration so that they can be safely used in the boiler. Okay, another byproducts produced in the waste treatment plant is called fly ash. That's different from bottom ash. Fly ash is categorized as a hazardous waste because I think it contains some level of the heavy metal that is toxic to the environment. So you have to give that a special treatment before they can be landfilled in a specialized landfill. So again, the practiced technology, I think, is pretty standard. We call this process called solidification. So you just confine the fly ash in a block of the cement. So to prevent this toxic ingredients, heavy metals being leaching out from this fly ash and getting to the environment. So that's how we treat the fly ash in Kanto and in other plants in China. And then there's another ash is produced in the WT plants called bottom ash. And the bottom ash, I think the portion actually could take up to 20% of the total waste input into the incinerator, into the plant. The fly ash is much smaller, it's 3%. So bottom ash is much more, 20%, up to 20%. But luckily, bottom ash is pretty safe. There's no toxic ingredients contained in the bottom ash. So the treatment is much easier. I won't say it's treatment, I'll say use. You can find a purpose to reuse the bottom ash because they are just aggregates. They're like sands and the cement particles. Add some additional aggregates, they will solidify together, and then you can put them into, let's say, use for the pavement of the road and other construction purpose. So in that way, actually, the bottom ash treatment could, if you do it pretty well, it could generate some revenue, additional revenue to your plant. Okay. The next slide just highlights this Kanto plant, the significance and social impacts it's produced. And also, this plant is not just important to us. We're pretty proudly we have successfully developed such a plant. It's also being featured in other high-level government talks, such as the ASEAN China Special Relationship Summit. I think that plans is featured in the talks of the heads of the several national government. Okay, the next slides, just give you some up of the meaning, again, this positive social impacts of developed Kanto plan that it has for the local neighborhood and the municipalities. I think our efforts and our achievement has been fully recognized by the local government and also by the Vietnam government, which would make it much more easier for our future development for this country. So that's one of the most important impact, I would say, influence to having such a plan developed in that region. And also Kanto is pretty, I would say, pretty important city in Vietnam. It's not big, but its location, the geographic location is pretty strategic. And also I think it's a tourist city in the Mekong River Delta region. So that's also will bring some political and also economy influence to this local region. Okay, now that's the end of my first case study. That's the WT plans in developing economy. The next few slides will be walk you through a different process to develop such a plan in a developed economy. I know I don't have much time left, so I'll try to accelerate. So first, I will give you gives you a brief look of how this legislation looks like in EU, because in European Union they have a very, I would say, different waste management objective compared to China and other developing countries. So maybe 15 years ago they already have developed such a waste management hierarchy. That's give you the priorities how to treat waste. They prioritize, reduce, reuse, and recycle, and then processing, recover, disposal comes in the last. The last one, of course, the least favorable one is called disposal or landfill. And this other recovery method, WTE is one of them. It's just one level above the landfill. So they are not really a favored method in EU region. This slide gives you a idea, a glimpse of how the situation, how the waste is managed in 27 EU countries plus UK, Switzerland, and Norway. You can see in the Scandinavia countries and other more developed EU countries, especially Austria, Germany, Netherlands, and Belgium. The landfill is really, really small. It's also negligible. It's less than 5%. So most of that waste are either recovered or recycled, or just processed by the incineration technologies. If you move to the east part of Europe, like in Poland, Lithuania, and also south part of the EU, Spain, Portugal, and Italy, the waste management is not that good. There's still a significant portion of waste goes to the landfill, and the recover, also less than say 1/3, and the WTE method is around like 10 to 20%. So during the past, I would say 10 years, those countries has this urgency to tackle this issue that most of waste still landfill. That's why actually in the later part of on my slides, you will see a tendency, a trend in the last 10 years that the WTE plan is being built pretty rapidly in those countries. I'll give the example in Poland because that's where China Everbright is present in EU. Okay, here also I'll spend like 2-3 minutes to give you an idea what China Everbright is doing in Poland. As I said before, in 2016 we acquired a waste management companies, Econowago in Poland, but they're not using. We're not using the WTE, the thermal technologies to treat waste. we're using more widely used method in Europe that is called MBT. This is the mechanical biological treatment. Currently, we have 6 plants in Poland. We use this MBT to treat waste. A portion of that cannot be recovered or reused. We go to landfill, and a portion of that we use that to produce the RDF, and we send them to the cement plant as the fuel for them. So that's how one of our plants in Poland looks like. It's located in a small town called Qunxing. And in this plant, you can see it's very different from this WT plant. There's no stack. The plant is much more simpler, but they require a larger footprint because they are using the MBT technologies to treat the plant. And this is a process, the diagram of the MBT. This is not today's discussion, so I will not go through this part because today I think we're more focusing on using the WT thermal conversion of the waste. So in the past 5-10 years, Poland has built about more 8 or 10 plants, WT plants, for that country. Most of these plants are owned by the government. And very rarely do we use this PPP, this partnership. Why is that? Because as I said before, Poland and other southern and East European countries lags behind compared to their more developing peers in treating the waste. So the EU really wants to help them to reduce the portion waste that is landfill. So the EU gives them a very high incentive to build WT plants to help to fight for the illegal dumping. So that's why those plants are not developed by any private party company. They are by EU, of course, through the government. So the EU gives them a huge amount of subsidies to build such a plant for Poland. But in this way, the gate fee they received is very low. So the purpose of this plans is mainly focused on solving this waste management problems for local government. So they're not looking to make a profit. So that's why the Polish government, they have the subsidies from EU, and they use the subsidies to build such plant, but to treat waste, I would say almost for free. So they will not have, gate fee, and also the energy price is way lower than the market price. But that's really applied to our case today, because they are more like government facilities, 100% own them, with a sole purpose to treat waste, not to generate the profit. So it's not applied to our case. That as a company, another important goal is to help to solve the problem and also generate the profits. So that's different. So here is the how a business model looks like for a WT plants that is developed in EU country. I would say the structure is pretty similar to what you see in Kanto, but its structure is different, but it's totally different a business model. Why? Pretty simply, the two ends of the revenue, one is gate fee, and one is the energy sales. They're not guaranteed at all by any government. The waste gate fee is market-driven price. It's really depends on your demand and supply. That will determine how much the waste that the producer is willing to pay you to get rid of that waste. And on another end of the revenue, which is the energy sale, again, that is determined by the market, how much the energy users willing to pay to buy that waste, to buy that energy. So that's the two ends. It's very different. There's no guarantee. It's all market price. So that's the difference. Okay, here it's just one of the WT plants, how they looks like in Poland. This plant is called Qunxing. It's not owned by China Everbright. We don't have any plants, WT plants in Poland. So that's owned by the local government. It's another small city. It's small in Chinese standard, but it's not small in Poland. I think it's pretty medium-sized city in Poland, Qunxing. So this plant has capacity of 94,000 tons per year of the treatment of processing the waste. That is a pretty standard size capacity of such a plant in EU. Much smaller than China, but no, that's how much waste they would produce to meet the demand of such a plant. So that's a pretty reasonable capacity in EU, but much more expensive. You can see the total capex of such a small plant is $85 million, and that's excluding all the tax and other things. That money is actually 6 years ago was 2016. So in today's standard, it will be even higher. I would say 30% higher than this capex. And that price would be, I would say, 3 to 4 times more costly than developing such a plant in China and also in other developing nations such as Vietnam. Those plants is old, is pretty old, so they only need to reply to this, standard that currently in use. But the new plants, I would say, if we try to develop a plant today in Poland or in other part of the EU, you need to go to this so-called BAT 2019 emission standard. That's just much more strict than this currently standard in use. That will driving up the cost even further. Okay, here is the implementation schedule of developing a plant in, I would say, in EU and Poland. So that's an example for Poland. So from the really planning stage to the end of the construction and operation, it takes 6 years. Why? Because the construction, takes longer time, and also the before constructions, various of the application approval of the permits takes much longer, because in EU they'll have some public hearing, also protesting is much more common. So that's why it would take much longer time. And in EU, the government involvement is smaller, and also the incentive for government to build such a plant is much smaller than other developing countries, because they don't have this. They have the plants already, so they usually don't have another urgency to have another plants to build. And also they will receive protesting the complaints from local government, also reduce their determination to build more plants. So that's the idea. And that 6 years actually is if everything proceeding smoothly. If there's other uncertainty involved, for example, they're protesting, the process will take much longer. And then this what we propose 6 years. Actually, I would like to share one example that in Poland, there's one project is called Kamianka, a project that we tried to develop in past years. That Kamianka project actually was I would say the permits first started in 2010, so that's almost 10 years ago, and it's still in this part, in public hearing stage, because it's continuously to receiving some attentions, I would say unwanted attentions from the environment organizations. They don't like this plan, they will go protesting, they will raise their complaints to government, and government have to stop to address this concerns, and also have a series of public hearings to address those issues. That all contribute to this prolonged period of the development period for plants in EU. Okay, to sum it up, some of the key differences for developing WT plants in EU and in Southeast Asia. WT is more favorable, in these countries, but it's less favorable in EU. And usually they can be built for larger scale because they have such a demand to have a bigger plants to treat more waste. The EU, the scale is much smaller, and the cost, either both in development and operation cost, is much lower in Southeast Asia, but much higher. Not just 100% higher. I'm talking about like multiple, like 300%, 400% higher in EU. And they have a shorter period, development period in Southeast Asia, and much longer period. In EU, and again, in those countries, you have a very strong support from the public parties. You have the subsidies. In the EU, not anymore. In Poland, maybe 10 years, but now, no, everything is private money, private funding. So you have you are on your own, and this revenue in Southeast Asia, the revenue majorly comes from the energy sale. But in EU, no, that usually I would say 30% is come from the energy sales, and a majority come from the gate fee. And in those countries, the gate fee and energy sales, all sorts of revenues are guaranteed by the government. So the developers do not need to worry too much about this risk. But in EU or other developed countries, this is all market driven. So there's a variables, variable prices, and this volatiles, especially like say, for example, in this year in EU, as you heard, this the conflict between Russia and Ukraine really drive up the cost of energy significantly. So we are facing a much more volatile price here in WTE sectors. So the risk is much higher of the uncertainty. So the developers really take cautions when we're trying to develop such a plant in EU, because market situation, you have to really consider how that will impact your return for the next 10, 20 years. Okay, that's the end of my presentation. Appreciate your time to listen to what I just presented. Thank you for your time.
Thank you so much, Troy. Very great presentation. Very detailed, and we learned so much things about the international development of Everbright, especially in Southeast Asia, Europe, and I think we're looking forward that Everbright expands in Africa, which is our aim. Since we are American University with our partner. Zhejiang University, we want to collaborate all together to support, African countries, to be equipped with such technology to overcome, the challenges of the waste management. So thank you so much, Ken. And now we'll, move. I will present the next slide. Basically, my colleague, Professor Thanos Pursalas, actually he's in meeting with the UN regarding the issuing, the report of the PPP, the guidelines of the PPP, the public first, public partnership within the UN. So he will not be joining us now, but I will present instead of him. So actually, I'm gonna share with you my presentation. Just give me a second. Voila. Okay. Okay, there we go. I think if you can. Okay. Okay, so I hope that everyone could see my presentation now. Okay, so it's okay. I don't see any message here.
Hey,
okay, perfect. Yeah. Thank you. So my name is Rebecca Baj. I am I'm a research associate at the Earth Engineer Center at the University of Columbia, and also responsible of international relations at the Global WTE Council, which is a project founded by the Columbia University. So just a brief introduction about what is WTRC. So the WTRC is the acronym of the Waste to Energy Research and Technology Council. It was founded in 2002 by the Earth Engineering Center as a non-for-profit association, but it has been a project within Earth Engineering Center since 1997, and it was founded by our founder, Professor Nicolas Semilis, who is a professor at emeritus professor at Columbia, and is the one who found the Earth Engineering Center and also the Global WTRT Council. So the EEC, which is the Earth Engineering Center, is the engineering unit of Columbia University Earth Institute, and one of its missions is to develop technologies that can help the sustainable development of Earth issues, which is mainly focusing on the resources such as minerals, energy, water, and also protecting the environment. So over the years, we bring all together several universities around the world to form a coalition, to bring all together, experts from different backgrounds to support and advance the sustainable development of the waste to energy. And as I mentioned, we create, form the WTRT Council, the Global WTRT Council, as a non-for-profit corporation registered under the law of New York State. Since we want to expand abroad and support government investing in research and development that will allow us, this statute allow us to achieve our mission. So several of our missions are the first as to identify the best available technologies for the recovery of materials and energy. Since, as you can, notice from all the presentation, from all the academia and industries, that waste energy could recover the energy and materials from the bottom ash and the fly ash as aluminium, copper. So obviously, the second thing is we want to conduct research and development, in several, countries to investigate the potential of waste energy in several countries around the world. And the last is to disseminate this information by means of publications, the web, and such as the workshop, this kind of workshop. And this is one of our aim, is to share information, make it available online and for free to everyone to learn and to learn about our findings, what we, the research that we invested, to share it to the public. So basically, our, the objective of our, network is, to advise government that sustainable management of waste must be based on science and best available technologies, and not what seems, that today some technology is not expensive, or some practices is not very well, not sustainable. But unfortunately, in the future, it's going to be very costly for our future generation. That's why it is better to invest in the right and just best available technologies to overcome the challenges in the future of the waste management. So in this presentation here, you can see the Global WTRT Council hierarchy of waste management from Columbia. So as you can see, we separate in two aspects: the recycling and the post-recycling waste. So for recycling, as you can see, it's waste reduction, reusing, recycling, and the anaerobic digestion, aerobic composting. That's based, of course, based on source separate materials. This is what we our conception of the recycling. But our main concern is all this effort of recycling. What's left over? How should we focus on what's left over? That's what we call the post-recycling. And our aim is that all this post-recycling, all the effort of the recycling, they should be managed to a waste energy facility that we can recover energy and materials. And as you can see, up, on the bottom of the waste to energy, there is a modern landfill recovering the CH4, which is the methane. Of course, there is some, possibility that some cities could not recover the CH4 and could only flatter the CH4, the methane, or without capturing the CH4. And unfortunately, in majority of low income countries, there is incineration landfills and open burning that it is very bad for the environment. As you can see, we are present all over the world and in all the 5 continents. Today, we are, englobing 24 nations around the world, englobing more than 27 academic research institute partners. And we are very proud to have the Cairo University as our partner in Egypt. And we are very proud of our Professor Mohamed Sour, who is the head of the WTRT network in Egypt. And our aim is to bring all the universities in Egypt and also all the people attending this workshop. And you are very welcome to be part of our network. And also in Morocco, we have our partner, the IRSN, which is an entity founded by the Ministry of Energy, focusing on the solar and the new energy, energy. So also we welcome all the members of a Moroccan team, to join our association. So our team members are, we're several backgrounds and several experts, who form our team, as Professor Tian, which is the founder of the Earth Engineering Center and the Global WTRT Council. Me as responsible international relation of the GWC, and also I created chapter in Canada and also in other several countries. And of course, Professor Huang, that has been presenting today. He's our responsible for academic, and others, Zhejiang, which is responsible for engineering, and Professor Robert Salas, who is responsible for the global development, and Professor Bauer from Germany. He's responsible for the IT and technology development. So some major achievements of GWC since its inception. So we have made a lot of research papers that we presented on our website, wtrt.org, that you can find several publications and theses available. You can download it, and several books, a lot of resources regarding all the means of the waste management. Also, we have done US survey of the waste management in all the 51 states of the in United States, and all the data that has been issued from this report, it has been used by the EPA, which is the Environmental Protection Agency, in computing the greenhouse effect of managing municipal solid waste in the US. Currently, I'm doing a research regarding all the potential of the waste to energy facilities across Canada and United States to calculate the potential of all the waste energy facilities and their capabilities, and on all the data to update it within the 2023 data. Also, GWC has been recognized by most association in Europe, like CWEP, which is the Confederation of European Waste to Energy Plants, and also the American Society of Mechanical Engineering Engineers, which is ASME. Also, the GWC co-authored the waste management section of the 2015 assessment report of the IPCC, which is the Intergovernmental Panel for Climate Change, and also supporting the being member of the Technical Advisory Panel of Singapore Environmental Protection Agency, regarding the beneficial utilization of the waste to energy bottom ashes. As you know, Singapore, they use the ash for building an artificial island. As you can see, there's some, that's the authoring report that we supported during the ICCWtE and also for the IBCC in 2014, that we introduced the waste energy as technology that is sustainable, as necessary for the circular economy and for the sustainable waste management. Also, we had also one of the most comprehensive database regarding numerous publication and dissertation regarding advancing sustainable waste management, and it's available online on our website at the WTRT.org. Also, our founder and director of the Earth Engineering Center, the former director of the Earth Engineering Center, Professor Tian, is one of the faculty winner of Columbia University 2015 President Global Innovation Fund that has been awarded on one of the greater projects that we provided to the waste management to the worldwide, which is advancing a global report regarding advancing sustainable waste management in Latin America and disseminating this result to other developing regions. This guidebook is available also online on WTRT. I advise you to go to the website and upload it. It is available in several languages, and I'm currently working on the French one. That obviously it could help the francophone people to learn about it. So the origin of this guidebook is on 2011. The Inter-American Development Bank engaged our institute, the Earth Engineering Center, to provide the guidebook on sustainable waste management that will support the Latin American countries and Caribbean cities and how to proceed with selecting the best waste management technologies and how to be, to support them to executing, multi-million projects. And this guidebook, as I said, is translated to several languages, including Spanish, Portuguese, Greek, Chinese, and I'm working, as I said, in the French one. We conducted several pre-feasibility studies during our courses of research in several cities around the world, as in Greece, Argentina, Chile, Pakistan, Uruguay, Mexico, and also Chile. Currently, we're supporting the country of Kazakhstan, to support supporting the government in implementing waste to energy facility. And hopefully, we are looking forward to collaborate with the Egyptian, Moroccan, and Tunisian government to support, implementing such technology based on science and technology. As you know, during the UN, the United Nations General Assemblies, a lot of several, head of the state, they came to New York, and they came to our universities seeking for information, data, how to seek what's the best practices to manage the waste. And one of the examples that the First Lady of Turkey, she came, and Professor Temelis held a meeting with her, including Professor Sachs, which is the UN advisor, which is the UN advisor of Antonio Guterres regarding the SDGs, the Sustainable Development Goals, and including others members of our faculty. And hopefully, this meeting was very successful since this meeting was held in 2018, and in 2021, the Turkey followed our advice, and they go and they build the waste to energy facility, because according to our 25 years of in-depth studies of all the means of managing waste to energy facilities, there is only two options: landfilling or waste to energy by combustion. And we provide scientific truth, scientific advice, and academic advice regarding the best available technologies, and we are very glad that they follow that. As you can see, our university has several, network around the world. At the Columbia Global Centers, we have 12 networks around the world, and we get involved with these networks in several cities around the world, such as Mumbai in India, Santiago in Chile, and Rio de Janeiro in Brazil. And we held several workshop meetings like that, like this workshop of in North Africa, to disseminate, which is also our aim is to disseminate, share the information to the public and the key stakeholders regarding the best ways to manage the solid waste management. Recently, we created our regional chapter of WTRT Asia, hosted at Columbia Global Center in Beijing, which is our home of all the network of our Asian network. And the aim is to bring all the key stakeholders, all the industries, academia, and also bring in experts in the region to advance the sustainable development of waste management, more particularly the waste to energy, and supporting the African nations. And this workshop, it was as a result, it was the result of this event that was held on May, and we were discussing that we need to organize an event for North Africa, starting with North Africa, and support these countries to implement a solution and be influenced by or sharing the experience of the Chinese success stories to support them, support these nations to implement and expand technology, Chinese technologies, and serve other nations. Also, we during the COP27 in Egypt that was held, we issued some letters, scientific letters, to the president designate of the COP27, which is the Minister of Foreign Affairs of Egypt. And also during the COP27, we provide a scientific letter that we issued with in partnership with Professor Huang that he shared during the COP27. Also, since we participate also in the public hearings in Canada, for example. So during 1 year, before, I think during the COVID, unfortunately, in 2021, there were 1 year of public hearing regarding the government of Quebec in Canada regarding the Ministry of Environment issued a public hearing to investigate what is the best option to manage the post-recycling waste. And in January 25th, 2022, the PAP, which is Office of Public Hearing of the Environment, has finally published the report after, as I said, 1 year of investigation. And one of the findings that the Commission stated about the waste energy technology is, I quote, "Several thermal processes used in Quebec and around the world will also analyze. For example, incineration of municipal waste is a technology that is widely selected in Europe, mainly for energy recovery and for reducing the volume of waste to be landfilled. And based on European realities and experiences with waste incinerators in urban centers, and after evaluating the context of their insertion and considering economic, operational, and environmental consideration. The Commission of Inquiry is of the opinion that this technology is mature and can be of interest in certain contexts. So obviously, you know, the Commission support the waste to energy, which is we call incineration, but I think in the terminology, incineration is not very well because combustion is not only combustion, but we use the combustion to generate energy in form of electricity and steam. So that's why I don't like the termination of terminology of incineration, but mostly we use it waste to energy. So, and they don't recommend other technologies such as gasification of pyrolysis that are not suitable for the municipal solid waste. And this report is available. This is the website. This is the link. I'm going to share with you all this presentation, and it's available in English and also in French. So this, you can be inspired by 1 year of findings and report that could be helpful for you for further investigation. I just want to highlight one of the projects, you know, working in Canada, which is one of the waste to energy facilities located in Quebec. You know, 2 years ago, the city, which is the facility is owned by the city of Quebec. They invested on the pipeline to supply the exhaust steam of the waste energy plant to an hospital. And as you can see on the map, you know, the location of the waste energy facilities is being linked with the pipe of more than 2.2 kilometers underground to supply the steam. And the benefit of linking the steam, the waste energy facilities to the hospital has saved a lot of money of the taxpayers, of Canadian taxpayers. And without the energy from the waste energy, the hospital would have used the natural gas generated that has been, you know, of course, it will be increasing their operating costs. And also at the same time, if the city didn't use the waste energy facilities, they should ship, you know, all the waste to a 200 kilometers way out of the city, which is, you know, another burden for the taxpayers in terms of the transportation and the processing costs. And also, you know, this project addresses several sustainable development objectives, which is improving human health, providing quality living environment, and developing a circular economy, you know, project by creating value from residual waste, which is the post-recycling waste. Instead, you know, as I said earlier, this example is very important that, you know, one of the good beneficial use of the waste energy, which is the steam, could eventually, for example, of Egypt and Morocco, could be used in industrial, and we call that industrial ecology, that one facility supplies an energy to another one, such as industrial plant or even desalination plant. I know that some desalination technology use thermal treatment that could eventually, you know, using the waste energy as sort of electricity and steam at the same time. So the environmental benefit of this project, you know, the hospital is entirely carbon neutral, and the greenhouse gas emission is reduced by 10,000 tons of CO2 per year, which is about 95% less than approximately 2,500 cars. Also, it has reduced drinking water consumption by 60,000 million liters per year, equivalent to 2,080 foot above ground pools. And it has improved air quality in the area surrounding the hospital site. I think, there is the city of Casablanca, which is in Morocco, which is representing like 4.5 million in basin and generate 1.5 million tons of municipal solid waste. Is looking for an alternative, to a small controlled landfill. I think approximately 35 hectares adjacent to the old non-regulated landfills in Medina. Unfortunately, with the shortage of the land for sanitary landfills and public opposition to the landfill, I think the waste energy is much needed for a big metropolitan city in Casablanca and also for Cairo and Tunis. So a science-based review of the fact would argue that the waste energy is only the solution for Casablanca. And we calculate that if the city implemented ICCWtE, it will, of course, reduce the landfill. And also one of the aspects is the greenhouse gas emission that we calculate it will reduce at least 1 million tons per year. This is I took, there's some pictures I get from some, network in Morocco, and the city of Casablanca itself, this landfill, it's gathered 35% of the Morocco municipal solid waste gathered in one place. This is not sustainable. These pictures, honestly, it's frustrates me because, the city of Casablanca aims to be one of the capital of, major capital financial hub, but doesn't look good. And therefore, we need to overcome this situation and implement some solutions. So therefore, one of the workshop is the aim is to overcome these challenges and implement technology that we will look in for the next slide. One of the advantages of the waste energy, of course, is has several advantages. One of them is the destruction of the pathogen, the conservation of the land, of course, this greenhouse gas emission reduction, and the recovery of energy and materials, from the post-recycling waste. And I just want to say, as you can see from several presentations, that waste energy is complementary to recycling. There is no competition of each other. As you can see, the best countries in the world in terms of the waste management, they are recycling waste and burning waste, such as Japan, Sweden, Netherlands, and Belgium. It is not competing, but unfortunately, let's say there is a lot of misinformation, or they do a lot of propaganda that no, if you implement waste energy facilities, it will harm the recycling programs, which is false. Based on the facts and the data, this is absolutely wrong and nonsense. So, based on the ways of our research, there is, what is the rational ways of managing waste? So, of course, there is recycling. This is the aim of it, as I presented earlier, the hierarchy of the waste, which is based on the source-separated waste. It can be used, as the materials or composted to soil condition, as the compost. And also, this is our main focus, which is post-recycling. What to do with all, the materials remaining after all possible and practical recycling. You mentioned practical recycling. And basically after 100 years of R&D, there is only two options of dealing with post-recycling, either with the sanitary landfill or thermal processing to recover energy, in terms of electricity or steam and metals and minerals. So I want to share here with you some one of the studies that Columbia made for the city of Milano in Italy. So Milano is a very good example for intensive recycling. That Professor, we notice it and we observe. So the population is 1.35 million people, according to the census of 2015. So 80% lives in the high-rise buildings with several households, and the city collects 3 streams of recyclables: the paper, the glass, and metal, with something, some types of plastics. So, and the 4th stream, they of compostable organics, and the 5th one, the stream, is to go directly to the waste energy facilities. You know, and the city provides 5 collection bins, like each bin with each colors, to each multi-story building in each house. So, for example, if you live in one building, on the garage, or mainly in the garage, you will have 5 bins. In the house, the same thing. So basically, also the city provides, you know, a small container, like a container of the food waste that you can hold in your house, and also they could provide some compostable bags that you can find it on the store with 1 cent euro, you know, one cent euro, you know, that you can use it for the waste container. So in this picture, this is how you know, the waste is sorted in separate colors. The transparent bag is in sorted waste, yellow bag for the plastic and metals, and also it mentioned the frequency of the collections. The transparent one, the white, is twice a week. The yellow for the plastic and metals, it's collected once a week. The white container, which is for the paper, it's collected also is once a week. The green one is only for glass, and it collected also once a week. And the brown containers, regarding the food waste, is collected twice a week. So the recycling regulation in Milan are very strongly reinforced. They are very strongly reinforced by periodic inspection by the city government of the material discarded by residents in the various recycling bins. Basically, if you implement a law and it is not reinforced, honestly, it's not a law. So that's why if you really want to invest in the recycling, you need to implement a reinforce by, you know, regulations and also by inspection, so to control the effectiveness of the sorting of the waste. So there is infractions, you know, if it's heavily fined. It costs approximately $200 fine on a building if they do mistakes on sorting the waste, which is very heavily. And all this effort of the city of Milano, they somehow succeed to become one of the very good example of managing the waste management system in Europe. And for the next slide, I will share with you the result of all these efforts. So the city, you know, they collect the papers. This is the tons per year they collect for the papers, the plastics and metals, and the glass. So all the total recycles represent 23% approximately. And regarding the composite, which is if you remember the brown bins, it's approximately 70%. So the total recycled and compost represent approximately 40%. And the rest goes to the waste energy facilities that the city don't send any waste to the landfill. Everything is managed properly. Did you notice something? That all this effort of the city to implement 5 sorting of the recycling, they just achieve 40%, only 40%. All this effort to sort the waste, and with implementing control and the fines and regulations, only 40%. So all this blah, 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 and the association says, well, we don't need waste energy, only with recycling, only with reducing waste, we can achieve 100% of waste management, which is false. this is a case study that, we need a good recycling with the waste energy facility to achieve a circular economy of waste management. So the question is how Morocco, Tunisia, and Egypt could benefit from the China, on the success stories of managing the sustainable waste management. So as you can notice from several presentations from the academia and industries, China has succeeded and demonstrated on the reality that they could reduce the capital cost of the waste energy plant by means of dedicated industrial academic R&D, rapid growth of industries, instead of custom building one plant at a time, because, in the US or in Canada, we built one plant per 20 years. But in China, they built 40 plants per year. They achieved to an assembly line fabrication of waste energy equipment. Also, there is a favorable national policy. For example, the states provide $30 per megawatt credit to waste energy electricity provided by the developer. And also, they placed the WTE in the Belt and Road Initiatives for funding. Ethiopia, the city of Addis Ababa in Ethiopia, is the reality, is an African dream that thanks, to China, they succeeded to build the first waste energy plants. As you can see, the old picture of Casablanca with Addis Ababa, it is feasible. You have to see it to believe it. It is feasible. I repeat again, it is feasible. And if Addis Ababa made it, Cairo, Casablanca could make it also. And I advise, if you could make the trip to Addis Ababa to see it by your own eyes, go for it, because it will give you some energy or or motivation, to fight for your country and build it. Some figures about the waste energy plant in Addis Ababa we call REFI. The capacity of it is 400,000 tons per year. It mainly comes from the municipal solid waste. It has, 2 great fire lines, and it generates 20 megawatt of power. Also, it has a very, latest technology of the flue gas treatment, and it was commissioned on 2018. And actually, China Everbright supplies some technology to the waste energy facilities, and also our association, the Global WTE Council, supports the country by holding several meetings in either Brussels, in Europe, and also in Addis Ababa, to support and advise, the government to go for these technologies and the waste energy technologies, and they made it, which is very impressive. Unfortunately, due to the context of the development of the waste management of in Ethiopia, there was some unfortunate event that before the city was using only open dumping, non-controlled, and on March 11, 27, there was some incident, the garbage landslide in the old landfills that killed 150 people and left dozens of other missing. So, the landfills is a threat, not only about the climate change, but also at the human. So therefore, our aim is to support Africa, because we cannot leave the continent alone without support, with technology, with support, and left them alone. Because if Europe is well developed and we leave Africa with no technology, without development, it doesn't make sense. We need to work all together to support the African nations. As you can see here from the this figure, according to the World Bank report, Water Waste 2.0, the waste, the generation of waste from on the 2030 and 2015, it's going up, not down. Therefore, we need to tackle the waste management because it's going to be one of the greatest problems in our next decade. And as you can see, the fast-growing waste generation will be in the sub-Saharan Africa. So therefore, something need to be done, and we need to act now and start working all together. Because if we leave African countries alone, it will be a lot of, unfortunately, events such as big landfills, not controlled, and we hear a lot of, unfortunately, bad stories. I think yeah. So, there is also one of the very important aspects regarding the super nexus age means for the sustainable technologies. As you can see, there is a lot of, investment of, take out a lot of resources and increase the demand due to the economic growth. It's going to put an enormous pressure on the availability and cost of the conventional resources. And it's going to put pressures on the prices of supplies of conventional resources that will be driven by the projected transition of over 3 billion people into the middle class in China and India. So therefore, those people, when they're going to have middle class, they're going to consume a lot. They're going to use more electricity. They're going to travel a lot. They're going to buy a lot. And therefore, they're going to make a lot of pressure on the availability and the cost for conventional resources. Also, the sustainable, what we advise is the sustainable technologies must stand alone and not be dependent on other resources when possible. This is what we call the circularity of economy and sustainable development. That's why, it's also is that waste energy could be linked with some other, for example, the incineration plant, hospital. It will create some sort of circular economy that will reduce, for example, the gas, fossil fuels, and etc. Basically this, how the urban waste is managed in various countries. I think we already mentioned that, as I mentioned, that the best countries in the world, as you can see, the high rate of recycling, the high rate of the combustion, goes along with the recycling. So there is no competition, like, the recycling and combustion. So we already noticed it from several presentations. Unfortunately, there is a lot of misinformation regarding the waste energy in US and also in other countries that, as I mentioned earlier, that we don't need either waste energy or landfilling. Or 100 smart recycling, it's enough, which is, as we can see in the case study of Milano, it's only 40%. With all the effort, it's only 40%. So if waste energy facilities is much preferable to the, as a facility, why over 80% of global urban waste goes to the dump or sent into landfill? So the first reason is the waste dumping, or it costs practically nothing. And the sanitary landfill, sanitary landfill.
The sanitary landfill can be done for an over $40 per ton, and depending on the biogas capture, and also the high initial capital investment of the waste energy require gate fees of 60% per ton. When electricity price of the grid is about $60 per megawatt. So not taking into account, the external cost of the environmental cost of the landfills. The second reason is, there is a continuing misinformation within the general public as an external environmental cost of landfills. We study, in Colombia, that there is a lot of a loss of land, which is we estimated as about 200 million of 400,000 square meters annually in the US. The greenhouse gas emissions of landfills estimated by Professor Bursalas and Temnis, about 342 million metric tons of CO2, for the US. And the dioxin and mercury emissions during, there was a lot of fires international fires in landfills that generate, smokes and, in the US. So also some other obstacles of the expansion of waste energy facilities is the initial capital investment, as we initiated, and also there is, the gate fees and, all the, challenges of the misinformation, all the misinformation. So basically, how, the China made it, on the world leader on sustainable waste management is, the China rapidly growing cities were literally now besieged by landfills. For example, the city of Beijing, it was literally, besieged by 500 landfills, across, besieged around the city of Beijing. And the state implemented the national 5 years energy plan, included energy, on the waste energy facilities, and they included the waste energy in the Belt and Road initiatives, for funding. As you can see, the generation of disposition of the waste, municipal solid waste in China, the rate of the building or generating energy from waste is increasing over the 20 years. And also the total capacity of the number of waste energy plants are increasing, as you can see, there is 400 more than, I think, 2022, but recently there is more than 470 waste energy plants and more than 100 under construction. And this is the picture that one of the journalist, reporter, Huang Zhuoli, from the film Beijing Besieged by Landfill, he go across all the landfills, across the Beijing on the dots, on the yellow dots. And as you can see, it was besieged, there is 500 landfills. So as you can see, they move from the landfills to the waste energy because it is not sustainable. If China didn't act, there will be a lot of problems of managing the waste in this country. So as you can see, they succeeded on lowering the capex. That makes the waste energy technologies more cost competitive. Comparing to the sanitary landfills. We studied for the case of Greece that we showcase that if Greece goes for the waste energy facilities, it's going to be more competitive than the landfills. And according to our study made by Colombia, we analyzed several waste energy facilities, in the US and also Europe, in US and China. And you can see the capex of US and Europe is around $880 per tons, and the average 21 Chinese plant is only 230 tons, $230 per ton. But of course, these figures is based on the the cost, the operation costs in Chinese, the local labors and etc. But I think if we compare it to North Africa, I think it could be some similarity or maybe some incidence higher a bit. So I just want to mention here that according to one of the studies in California here, why I want to mention, why landfills of waste is not good options. As you can see, there is a lot of production of landfill gas. There is a lot of production of leachate, which is in the long term, the collection and the treatment is quite expensive. And there is a lot of engineering barriers that if we go on the large landfilling, it's not very sustainable. So, and also landfilling, if you invest in landfill, is like you provide problems to the future generation. And there is also a missing part of all the environmental costs associated with the landfill, because they focus only about the cheap landfilling, but they forget about the associated costs, including leachate, the remediation of and closure of the landfill after. And it's the landfill is never closed. It's you need always to maintain it and operate and maintain all the closed landfills. And I just want to mention here regarding the methanes coming out from the landfills in California. As you can see from the NASA plume airplanes, that they notice detections about a lot of emissions, methane emissions coming out from the landfills. That is very, very, very massive. That they are exceeding the regulation from the EPA. So therefore, if we want to combat the methanes, even with the best and sophisticated capture of the methane, there's still some leaking and also some fugitive methane still get out from the waste. So yeah, thank you. So basically here, I just want to close that Colombia has made some study about 6 MBT facilities in Europe that they use different approaches for the recovery of material energy from the mixed waste. And the result of it is we find out that these facilities that they are quite expensive, and they recover with a lot of investment. They just recover a little, like a little bit of RDF. So basically, we recommend, based on this report, that we can share it with you. We can share this report that we have found in the findings that the waste to energy facilities is using the combustion. It's more has a lot of valorization rates than the MBT. So so I think this report is very, unfortunately, Professor Burtsalas is not here, but you can, I'm gonna share with you this report, and you can, if you have some question, you can send to him an email so he can reply to you and provide you some insight and feedback. So I think I thank you so much for your time and I'm already here to to jump to all the the Q&A session, and I thank you all for your attention.
Okay, thank you very much, Mr. Rida.
Yes, thanks so much. So
Yeah.
I invite everyone, if you have some questions,
Yes.
you raise your hand.
I hope Professor Qunxing, Huang, and Mr. Tian I hear. Qunxing Professor Huang, are you here? Okay. Maybe, ladies and gentlemen, we have a time to have a communication and comments or questions for these presentations and also for our training workshop. You're welcome.
Okay, so Professor Muhi, you can start your question. Thank you.
Okay, thank you, Reda. Hello, everybody. Good morning, good afternoon, or good evening for those who are coming actually late. Actually, your closing, Reda, is really very, very encouraging that this is not really a local problem. This is international, wide problem, which is actually the waste. How can you manage that? How can you deal with this waste for generating energy and providing clean environment? I think the problem, Reda, is that actually decision making. I mean, to make a decision and also to attract investors for having this kind of implementation in a country like Egypt, I believe this requires a lot of work. And we hope that you can help us for doing that. So on our side, I believe we need some kind of national conference, local and face-to-face conference, and then we can invite people from industry, invite people from investors, invite government, and really we should be very well prepared for those questions, Reda, you have said, and those claims that they say, okay, recycling is the way forward to manage waste. I believe, as you said, we can achieve 50% at most. Maybe in Egypt we can achieve more because we have other ways of recycling, but I believe we will never exceed 60-65%. We still have at least 35-40% that requires actually some treatment, and as you said, that will lead to really polluting the environment, causing a lot of problems. For us, I think hesitations from investors came from these points. I mean, when you raise this kind of waste to energy, people say, how much it costs, how can we afford that, and the government feed-in tariff, etc., etc. So really many questions and many, I mean, worries, people worrying about going forward in this direction. There are some individuals who are actually convinced, and there are some, I mean, efforts to go in this direction, and these efforts are very successful. But I believe if it comes from the big umbrella from the government and trying to impose some law or give some, I mean, strict instructions, we should go forward for this, like Beijing, when they said, okay, we need to get rid of these landfills within maybe 5-10 years or so, like European countries, when they actually managed to have no landfills and stuff like that. So that's, I believe this is one of the way forward. I mean, COP27, we read this issue as well, and we mentioned that, and of course it attracts so many attentions. But I mean, like what you said, Africa really need more and more work, and with the help of China, as now I think one of the leaders in this technology, maybe we can transfer technology to our country. I mean, we don't have to import everything as turnkey plant, but maybe with some local technology, we can actually reduce the cost of these plants. So with the cooperation between China and Egypt, then some of the items which are built in China or Europe can be done in Egypt at lower cost. as you said, also the labor cost is less, and the type of the waste may be different, and many things like that. So I think we need to go forward. We need to really step forward and say, hey, this is how we should go for it. We need the many challenge to convince government, to convince investors, to convince industry, and to start to build actually industry in Egypt. Maybe in the future, on maybe long range time, that we can have one of the industry from China can have their own factory here in Egypt to build this waste to energy plant. So we can build it locally with China technology, with the help of the waste to energy center in Colombia, something like that.
Yeah. Yes, definitely. I'm 100% sure confident. And also one of the aspects also I want to add that, as you know, unfortunately, there is a lot of, tension, political tension between the US and China, but we are always, supporting the cooperation and the dialogue with our counterpart, the Chinese counterpart. We're always, working all together because I believe in the cooperation. If we don't cooperate all together, it is impossible that US alone or China alone could fight the climate change. It needs an international coalition, international collaboration. And as you can see from this workshop, is an example that this cooperation, that we together, Columbia, Zhejiang University, and also Everbright and others US companies, that we want to collaborate, finding a solution for the developing nations, more specifically in Africa. So, we are working, as you know, that within the next development of WTRT, our association with Colombia, is to, to create, to prepare for the next COP28 in Emirates. And Emirates is more advanced in the, the waste to energy technologies. We are programming a physical event, either in a pre-event in Qatar, Emirates, or even in North African country, hopefully in Cairo or in Casablanca. But we are still in the discussion. But definitely, one of the aspects is to hold a physical meeting and to bring all together and to bring all the stakeholders, the local stakeholders, to present and providing scientific truth, scientific evidence, and also academic support to convince, as you said, stakeholders, the president of Egypt, ICC, and providing him the findings and the best available technologies to manage waste. Not only a technology solution, but also the financial aspect, which is very important through the Belt and Road Initiative. And one of the things that we are, we worked last 2 months in New York, that we will create an event during September at the UN, held by Colombia. So this event, we're gonna take this opportunity with all the head of state, and we're gonna focus on the African head of nations, head of the states, coming to New York to organize, an event to, will be the first one, before the COP28. And we invite you, Professor Mahi, to come to New York during this period during September, because it will gather all the head of the WTRT councils, including Professor Li and Huang, to come to New York, because we're gonna create this event within the UN, to accelerate and make actions, not any more talks or discussion, but implementing a roadmap, for supporting the African nations, to support them with the technology transfer and also solution on the finance, which is one of the biggest challenge, for the African continent. Professor Lee, if you want to add something. You're in mute. You're in mute. Yeah, you're in mute. Yeah.
I'm sorry. Yeah, thank you. But I want to invite Mr. Tian from Everbright. Can you say some things? And then also Professor Huang here. We want to say also some things. Mr. Tian, do you have any comments to respond?
Yes, thank you, Professor, and thank you, Dr. Rita. This is Zhuoli. Actually, I don't have much to respond. I think Dr. Rita has covered, almost every aspect. I think I would possibly think to respond to Mr. Professor Marshi's comments, but maybe I just make one additional quick comments about Dr. Mahi, Professor Mahi's comments about like to proposed partnership between China and Egypt to build WT plants in Egypt or in other North African countries. I think, yeah, that's definitely a great idea. Of course, the partnership, can be many forms. Technical transfer is one aspect, but other part of partnership is also, I think, good in my opinion. Of course, as a China Everbright, if I am representing China Everbright today, because we actually haven't yet to explore. We did some efforts, but we haven't had a successful development in Egypt or in other parts of the North Africa. One of the reasons that we actually not understand the market there very well. Of course, if we try to enter that market, we would strongly prefer a partnership from local player, either from a company or local government. With that mutual efforts, we aim to build and develop a successful plan for that country, for that region. So that's our idea. Because China Everbright, the technology transfer is definitely one direction, but that's not where we expertise lies in. Because we're also, in the past 10-20 years of development, we are yet to explore this kind of partnership, how this technology transfer will work. So what we are more familiar with is just to have equity participation with our local partner and to develop such a plan in that region. So of course, that's just my idea. It's could be many ways of partnership. I'm just sharing one of the possible partnership that we are particularly familiar with. Now, can use that example to incentivize stakeholders and companies to build plans for Egypt and other countries, North Africa, under this kind of partnership. Thank you. That's my comments.
Okay, thank you, Mr. Tian. Professor Huang, are you here? Yeah, you're welcome. You open the voice. You should open the voice.
Oh, yes, I'm here.
Okay, you are busy. Okay, maybe you can say something. Yeah.
I just have dinner with my friends and near the campus.
Okay. Do you have any comments or to respond from Egypt?
I found a question from William. He is asking about how is the calorific value measured for mixed MSW to decide which incineration technology is most.
Professor Huang. Okay, maybe I can say something and then you can answer the questions. Okay. Okay. Yeah, Professor Professor Mercer. Yeah, I fully agree, and also just mentioned by Mr. Ridas. I fully agree that we should have the more effective cooperation and face-to-face in the future's cooperations. And in my opinion, if possible, if needed, in Egypt, in North Africa, any conference or meetings on, I believe the Everbright and our university or others Chinese partners are very glad to join us, join that, and to find some cooperation, potential cooperations. This is my opinions. And second is the exact the technologies, in my opinion, from the some developed advanced technology and then adopted by the China and the localizations is the big stories and also is experiments in China also. So this is very important for the Egypt or others, the African countries to adopt some advantage from China or from other countries, and then to apply in their country, in African countries and localizations, and more effective, more economic. And it is feasibility. And also, in my opinion, it is necessary. So just you say, we need to do more and more work. We need, maybe we spend time to have a training, to have research, have some industrials or industrialization or others, and also to open the mind of the government and open the mind of the public also. This is very important also. So much more work to do for this, in my opinion. And also, this year I have contacted some international friends from the southeastern countries. They put forward some for the special training. And also, I think Everbright, they have some the same feelings. For this workshop, for this training 2 days workshop, and also we provide this 2 weeks training workshop. That is the comprehensive. The academic, technology, and the policy or something. This is comprehensive the training, not for special the training. And also, according to our corporations, in the future, maybe for example, in Vietnam, in some developing countries, for special technician trainings for technology or for operation, for just like that, it's very important. And also, in my opinion, we should cooperation. We should cooperation with Egypt or cooperation Morocco and Paris, and to do such work if possible. And we combine some technology and some special trainings. It is very important, and we should do. So this is some response for your questions. So, Rita, we can continue, Professor Huang, to answer the questions.
Yeah, sure.
Okay.
Professor Huang, you can.
Yeah, Professor Huang, you can continue your.
Professor Li has mentioned a lot about how this technology can be applied in North Africa. I think the situation in North Africa is very different with what happened in China due to the national population and also the different cultures. And if you want to build a waste to energy plant, I think 2 things are very important. The first is the industrial level, especially thermal engineering industrial level, or you need a well-trained engineering to design the waste to energy plant. Also, you need well-trained operators to run the waste to energy plant. That's why if you take a look of the waste to energy distribution globally or in China, you can see most of the waste to energy plant is built where near the coastline in the developed cities. So the story of waste to energy in China, I think, is a very good example. You can see how the technology is imported from the European, and how this technology is localized. Our academia and industry do a lot of the technology localization works. One thing William asked is about the heating value of the West. Actually, 30 years or 35 years ago, the heating value of the West in China is pretty much low, because at that time we don't know we can do a bunker management. The bunker management has changed the story of the waste to energy in China. By of the waste in the bunker, we can significantly reduce the moisture content of the waste. Then the heating value of the waste was increased. Then the technology imported from the European and Japan can be used for mass burning of the waste. That's a very good example for the technology localization. I think if North America wanted to build the waste to energy, wanted to take care of this waste, you have to not only the academic, but also you need industry engineering to do a lot of the localization of this technology. Not only about the incineration technology, but how you manage the waste incineration system, how the waste can be transferred, how it can be collected, and how it can be generated, and how to take care of the residues. For example, classified as hazardous waste. But in the United States, the fly ash is mixed with bottom ash for landfilling. So it's totally different. So the government policy will change the scenario of the waste to energy. So you have to wear cooperation, not only with the industry, but also to work with the government. So you can to push waste to energy industry to expand. That's what I want to say. So another small question is about the heating value. So how we can decide which technology is more suitable for burning? Usually, the waste incinerated in the moving grade is ranging from 6.5 to 7.8 megajoule per kilogram. But heating to the incinerator, not the way heating value of received waste. For in some cities, the moisture of the received municipal solid waste is pretty high, 35 to 45. So you have to put in the bunker to digest for 2 or 3 days. Then we feed it into the incinerators. That's why I would like to say about the waste to energy. So thank you very much, and not much words. If you have any further questions, we can chat and we can communicate through the mail or through web chat. Thank you very much, Professor Lee. And
thank you, Professor. Thank you, Professor Huang. Definitely, of course, it is not, the last thing that there will be, of course, there will be contact. You can reach out to us, and through our website, through email, and also all the material, all the recordings. For the Egypt, it will be hosted at Professor Mohi web, the association. It will be available online, so you can upload it, and it's free. Of course, this is one of the mission of the WGRT is to disseminate information. All this material, the recording will be available for you. And also, if you could, join, if you could send me your emails to info@wgrt.ca with your name, last name, to create some sort of, network to continue, all right? Further discussion, brainstorm, what's the next, what should be done, next, and to all bring a collective intelligence, what is needed to be done. I count on every one of you who attend this event to share this out, what you learned today to your network, and think how I could support my ministry, my organization, or my institutions, and even my country, how we could advance together. It is important to work together. as one of the African proverbs says, that if you want to go fast, go alone. But if you want to go far, go together. So thank you all for all your attendance, and I am free to if someone wants to ask questions. If not, you have emails. You can ask later on, send us emails, and we will be very happy to reply to you later. Yeah, Professor Mohi, you can you have your.
Well, on behalf of the Egyptian Energy to Waste and also the Egyptian Society of Renewable Energy, would like to thank you very much for this very successful training workshop. I really got much more than what I was expecting. So thank you for every speaker, and thank you for the organizer, and looking forward to see you all here in Cairo, inshallah.
Thank you.
Thank you. Inshallah.
Thank you.
Definitely.
Yeah.
Definitely.
Yeah,
Thank
it's
you
my
so much.
honor. It's my honor. Ladies and gentlemen, and also I want to say, maybe Professor Huang, you can say, actually our university have a master degree program. Professor or any persons are interesting. If you have students, you can apply the master degree programs focus on in energy and environmental. So that is the good opportunity to the more closed cooperation for training for the person trainings. If you're interested, you can visit our website www.ICCWtE.org. We have announcement for that programs, and also you can contact. We have some contact information. You can check more detail. Okay, and again, for the exact technical or technology questions, for example, for the moisture, for some technicals, in China we have much experiments. For example, China is a large country, so we have developed areas and also developing areas. For example, Everbright already have many waste to energy plant in China, so they face the different waste in the different waste to energy. So for example, in developed areas, maybe the higher the heating value of waste maybe over 12,000 also 12 megajoule per kilogram. But for the low heating value or for the developing areas, maybe half. So for the Everbright or others, other waste energies, the company in China, they have experiments. How do they waste this waste? For moisture is only one topic. So we can reduce, we can storage over days and to reduce the need and higher the heating value also. And if possible, we can mix some high, for example, biomass or others, the materials or something just like that, if possible. So it depends. I believe Everbright have much more experiments for their ways, the technical problems. So if possible, we can keep contact to discussing or to find some feasibility measures to deal with the waste in the future. Okay. Yeah, Mr. Reed, I just say something about that.
Sure, absolutely. I want to give the floor to Mr. Diaz. He raised his hand. If you have some questions, please, you can go ahead. Thank you. You are in mute.
I have to deactivate my computer to talk from my mobile device.
Great.
Hello, everybody. Peace be upon you, all of you. I want to thank all of the speakers for that presentation. So I just say that we are really convinced and already convinced that incineration is better than landfilling, especially with our context in Morocco. You know that water is very important, and we know the problems caused by the leachate. I want to point at that, especially that we have a law 2800 that segregates all the waste, solid waste, at 3 classes. So we have the first classes related to the MSW, municipal solid waste, and the second class is related to the no hazardous waste, especially for industrial, agriculture wastes. And we have the last or the third classes related to the hazardous wastes. So if we reach that we can incinerate all that waste, we can incinerate also the class 2, the no hazardous waste, especially related to the shredded tries, etc. So from that we can see the importance of the incineration. Just I have to point at another thing that we have an experience here, but unfortunately not in the region Bni Mellal Khnefra, related to the treatment of the leachate. I don't know really what is the performance of that treatment, but I'm talking just about the costs. It costs between it's around 50 dirhams per meter cube. That's mean 100 dirham for 1 ton of MSW. So if we take that, the ratio of leachate recovered water is 0.5 or 58%. So I just want to ask if we want to apply all the solution of treatment of leachate here, is that, or does it cost the same thing, or more than that cost? And I would like that we adapt all the values, all the costs to the Moroccan context, okay, and the purchase power. We have not to talk with the dollar, so we have the Moroccan dirham. So and I also see applied. I want to ask about the $50 million that showed in the model business, the business model presentation. I think this third speaker or in slide talking about the business model, talk that we can treat that kind of and valorize all the MSW about $15 million for 22 years. I want to ask if, especially for 400 ton of waste per day. So I want to ask, is this cost is related to a linear function or is an exponential function? That's mean if we divided that volume of waste by 2 or by 4, we will have just 200 ton per day or 100 ton per day is if does we divide the cost to the by 2 or by 4. So this is if it's a linear function or it's exponential function, and also if we have more than 400 tons per day. And the last question, I'm a PhD student. My thesis is about circular economy applied to the topic of MSW valorization and treatment, in especially the province of Huang. I'm asking all the speakers and especially you, Professor Rida, there is an opportunity to coordinate with you in that topic or something like that. And I wish you a grateful day. Thank you.
Thank you. I appreciate it. You are the most active Moroccan who interacts with us. Thank you so much for your insight. And of course, we would like to collaborate. And as I'm a research associate at Columbia, I would love to collaborate with you to do some sort of research with your region, Beni Mellal. So yeah, no problem. We could definitely do some sort of joint research collaboration. And if you need any support, either Columbia or Zhejiang University, you are welcome. So I want just if Troy wants to add something to respond to his request, you got the floor.
Okay, thank you, Dr. Rida. I raised my hand. I believe Mr. DeHarge, he referred to my presentation in one of his questions. So I will try my best to answer his question. I think his question is about the cost, development cost of the WT plans. He saw a number that in my presentation, I think that's the cost for the Canto plant that is located in Vietnam, and that was developed by China Everbright. So his number he referred was to 50 million US dollars. I think his question was asking is that number is a linear relationship. If you build a bigger plants, the relationship is linear, and also for the smaller scale plants. My simple answer is no. The relationship is not linear, but of course there will be the scale of economy that will be played here. Basically, the bigger the capacity, and the unit cost will be lower, more affordable. Lower the smaller the capacity, the unit cost would be higher. But I would say 50 million US dollars for 400 tons per day is pretty standard price. If you remember Mr. DeHarge, I will try to draw your attention to Mr. Rida's presentation. I think in one of his slides, he have that unit cost for a developing country and also developed countries, EU and USA, and also developing country. I believe that number he said for EU, for US, 800 US dollars per ton. That's per tons per not per day, per year. For developing such plans, and for China and other developing countries, that number is 230 tons. 230 US dollars per ton. So I think you can use a number and then times that the capacity you aim to build, and that will give you, roughly more or less the total cost we would expect from building such a plan. But I just have one comment here. I think the 230 US dollars is cheaper, is lower in my understanding. Maybe the number is old. I think today's China probably approaching 350 US dollars per ton. So that's my latest estimate. Of course, that all depends on the location of the country and also the technology you want to use, especially I think the control, the APC, this air pollution control method you want to use, lower the standard, lower the cost. And also the other effect, the subsidies you receive from the government, other sources. So the cost is highly variable, depends on the region. But you won't have a rough number, I would suggest to use that number in Mr. Rida's slides. Use that as the, as your initial estimate how much that will cost to build such a plant. Times that with the capacity. That's my answer to Mr. Dahaj. Thank you.
Yeah, thanks so much, Troy. Also, Diaj, I will share with you one of the the pre-feasibility studies that we have done in the Caribbean with a small tonnage in the Caribbean. Then in the I think it's going to be very more practical, and also in some other Latin American countries. I can provide you this kind of figures that could support your research, to figure out the cost, and also to update the some figures regarding to your local context, and also if you need any exchange, you can reach out to me either by phone or by email. Will be very glad to assist you on that. So is there any other questions? So oh yeah, so from Ahmed Abu Naim, you okay? I'm gonna, if you could provide me your email, I'm gonna share with you the, okay, oh, you know what, I'm gonna share with you right now the technology. Yeah, I'm gonna share with you straight away now the document. So from the study that we have made from, I think this is the one. Give me a second. Okay. Okay. So I'm gonna share with you the.
Okay, Mr. Rida, I just mentioned, maybe I'm not sure today whether any person from Taurus to attend this workshop, but yesterday we have 3 persons from the Taurus to attend yesterday in the training workshop. I know. So, but
yeah. So I just want to ask.
They
I just want to confirm. Yeah.
Okay. Exactly. They are invited by the Everbright. So that means they have some communication or some communication early among the between Taurus and Everbright. So this is very good. It's very good.
Yeah, perfect. So just want to Ahmed Abu Naim. So the session technology and application case of solid alternative I presented, and I mentioned that at Columbia we have done a case study or research regarding the comparison of 6 NBT plants in Europe, and I share with you in everyone the report, and you can upload it. And apart from that, we're gonna of course create some sort of website that you can upload all the documents, presentation, including the recording. And even further, if you need any questions, any information, you are welcome to reach out to me, and I will be very glad to assist you. So if anyone has some questions, we will be pleased to respond. If not, I think we could just close this workshop, and well, we hopefully you get my emails. I would love to get your contact details, in order to create some sort of working group to continue working all together, and to advance, the sustainable development of waste to energy technologies in your respective countries. So thank you so much, and I hope that you had an amazing day, and you had a head full of information. And I think it's, for me, it's early now. It's 8 a.m. in the morning. It's time for me for a coffee to open my eyes. And
Mr. Rita, you're tired early.
Yeah.
So maybe I
Yeah,
can
and I
say
wish,
something.
Yeah.
Okay.
Yeah, sure.
Yeah, thank you, Mr. Rita. Exactly, we all of us should thank you for your excellence, for your hard work for this workshop. I represent our side. And also, it's my honor to cooperation with the Mr. Rita to organize this the training workshop. And also, I would say the same. We provide our contact information. If you have any comments or questions, you can send email to us. We already provide our contact information for you. We will do our best to respond to you, and also we hope to set up the more close cooperation relationship in the future. So you're welcome, and thank you for your attending and to enjoy our training workshop, especially for our presentation and also Professor Huang our presentation. So this is a short time and very short information. I hope to provide much more, and also maybe we can invite the important person from Everbright, Huang or Mr. Tian. Maybe you can say some things.
Of course. Thank you, Professor Lee, and thank you.
Okay.
Thank you, Dr. Rita and Professor Huang, all other people online. It's a good honor and also a pleasure to be able to join this workshop, to have hearing all this informative presentation, and for us it's also a good education for ourselves. So I would say in future we're looking forward to having more opportunities to be interacted with the community, and hopefully we can advocate such technologies and help other people in the world to help them to tackle this waste management issue, and to find a more environmental friendly and sustainable way to help just growth of our economy and the environment. Thank you. That's all from my side.
Thank you so much, Troy. We appreciate your participation and also the support of Everbright.
Thank you, Rita. Thank you, Professor Lee.
Thank you so much. So have a nice day, everyone, and I hope to get in touch with you soon. And
so thank you,
thank you
very
much. Thank you.
Good day
For all your efforts. The boy.
Yeah. See ya. Bye bye.
Rita, see you. Thank you, Mr. Rita. Keep contact.